Regional Office of ICAO. This is to increase the knowledge of the update of manual heliports document 9261. In order to start now, to start this event, we'll ask our Director General of the SAM's office to address to the audience. Good morning, Fabio. I can't manage to start my audio. There's some hosting a seminar. I cannot turn on my camera, but if you do not mind, I can just start. Over to you, please. Well, if I manage to start my camera, let me know. Good morning, everybody. It's a great pleasure to greet you. Thank you for your attendance. After a pandemic period, but the heliports issue is an issue that has not been discussed jointly in the region, if I'm not mistaken. Well, I can see it now. Well, we held an event about this in 2018, but we have not really had a significant event since 2014 on this topic. And now with this document, we updated in 2020, that was completed in 2021. That's document 9261 on this matter. The matter has been updated and it's been of great interest for our region. We are supporting the return of operations, commercial operations in general, and the progress made in our region has been the most significant in the world. Latin America has been the region that has responded more emphatically to the recovery of air operations. And we also know about the importance of helicopters in our region. And this has also had a recovery with the gradual economic response of our countries. The cities with large density of offshore operations, no doubt in the main cities, is one of the main demands that we have in this sector. And this is one of the greatest opportunities we have now with the growth of some helicopter operations related to offshore operations. And also, the demand is coming back to the largest cities in our region. So we see the need to discuss the technical aspects of heliports in our region. And besides that, the technological progress and the operations expected in the next few years regarding Heliports is a sector that will grow very quickly. So here we'll have a chance to discuss and talk a bit about that. I'd really like to thank all participants here and also panelists and those who have directly supported this effort regarding Project 06, all the South American states. Especially, we could highlight the support of Brazil, ESS, NASA from Spain, the Royal Aeronautical Society of the UK, that provided direct support, and our appreciation to the EUI of EUI of our headquarters, our aerodromes team of the South American office as well. So thank you very much, and may you have a great event. Thank you very much, Fabio, for your words. We will now start giving you some short instructions about this event. As Fabio pointed out, we want to thank all the participants in this event. We include the International Association of Oil and Gas Producers, the IOGP, EASA, the Royal Aeronautical Society of the UK. Now, this event has been planned to last a couple of hours, a bit more than 2 hours, with simultaneous interpretation available just by selecting the option on the menu. We will be recording this event in both languages. We will be sharing this through our website. The raise hand option will be off. The chat is available, but we kindly ask you to ask your questions through the UEA option, which is the Q&A option, and we'll try to answer as many as we can during the event. But if we don't manage to answer them all, we'll take note of all those questions, and then we'll share them in our portal. And finally, if you still have a question left after the event and cannot be discussed, then kindly send us an email to this address here with the subject 22 SAMHELI or Heli22, just to make reference to this event. At the end of the webinar, we'll have a short survey, so kindly take a few minutes to respond to it. And this is our agenda for today. Quite simple. We'll start with a short introduction from ICAO, discussing the work done by the working group, or the Heliport Design Working Group. And then we'll talk about offshore heliports and onshore heliports, including elevated heliports. And then we'll have some experiences of SASA out of the region, Spain, and in the region, Brazil. We'll also have a short presentation. That's a collaboration from IASA and SANASA on Vertiports, just to generate some discussion. And then we'll have a Q&A section. As I said before, the recording will be available on the website, but now it's available. The presentation will be, the recordings will be taking place at this moment. Well, that would be all, just by way of introduction. And in this way, now we can start with the first session, that is setting the scene, changes in Annex 14, Volume 2, document 9201. On this occasion, we'll have two speakers. Let me introduce both of them so that the presentation can flow easily. Our first panelist is Mr. R.C. Ryman. He is a technical officer of the interoperability operations of Heliports in ICAO headquarters in Canada, and secretary of the Heliport Design Working Group. Next panelist, I'll now switch into English, so our colleagues that are listening in Spanish can just test the simultaneous interpretation to introduce our next speaker. Our next panelist.
Our next panelist will be Jim Lyons. Captain Lyons had a career in the rotorcraft communities, spanning for more than 50 years as a pilot and regulator as well. The last 25 years, he has been dedicated to the development of international regulation and best practices in the field of operational safety. He's also a member, and he's representing the Royal Aeronautical Society of Rotorcraft Specialists Group since 1999. And he was elected chair in 2001 and 2003. He has provided several papers and keynote speeches and being awarded the Eric Brown Award by the British Helicopter Association in 2005. and MBE for Services to Aviation Safety by the Queen 2011. He has been a contributor to revisions to not only Annex 14 Volume 2, but also to ICAO Annex 6 Part 3, and had a principal author as well of documents 10.110 and 9261 ICAO documents. As I mentioned before, he continues to act as the Royal Aeronautical Society representative member for the ICAO Annex 14 Heliport Design Working Group and Helicopter Study Group. So I will give the floor now to RC for him to begin the first part of the presentation. RC, are you ready?
Yes, I'm ready.
The floor is yours. Thank you.
My video is disabled. It's okay.
I will solve that out. Sorry.
No problem.
About you.
Sorry, I'm trying to share my screen. Just give me a minute.
We see your screen now. Oh, did you turn it off?
Sorry, having a bit of challenge. Yeah, here it is. Do you see it now in presentation mode?
Yes.
Okay, thank you.
You're all set.
Okay, thank you. Good morning, all. It's a pleasure to be with you in this webinar on heliports. As Fabio introduced, I'm RC Raman, the technical officer from ICAO Montreal office headquarters, basically supporting the work on heliport design and operations from a secretarial perspective. At the outset, I would like to thank and convey my appreciation for the ICAO SAM region for initiating this action for conducting a seminar on this important topic and give good visibility for the extensive work done on this subject of heliports and helicopter operations. So this short presentation is more about setting the scene on what has been done by ICAO and what it plans to do. I'm sure the experts in the subsequent sessions are going to talk extensively on the technical matters. So if you look at it, ICAO has got two major documents, especially from the aerodrome section, that is Annex 14 Volume 2 on heliports and Doc 9261, the heliport manual. So this is a quick introduction about these two documents, and subsequently we'll have other sessions which are going to talk about in detail on the technical aspects of it. So going back a little bit of history on the background of this, the Annex 14 Volume 1 on aerodromes was published way back in 1951. The interesting thing is that even in that particular document, there were kind of some discussions on trying to have something on helicopter operations. Even though they were not introduced it, there were some discussions. And so this discussions continued, and looks like somewhere in the 1960s, middle of the 60s, they had published a guidance material on heliports. That's the first start. Thereafter, it was felt the way the industry is booming and evolving, there is a need to have standards and recommended practices exclusively for heliports. That's why in 1990, the first edition of Annex 14 Volume 2 on heliports came into existence. So as you see, the industry is evolving drastically. So what happened is there have been around 9 amendments incorporated till now in Annex 14 Volume 2 on various chapters, on various subjects. This indicates the amount or extensive changes that has incurred in this industry and the way we have tried to cope up with this through standards and recommended practices. And the latest 5th edition of Annex 14 Volume 2 was published in July 2020, just after the onset of the COVID pandemic. And the new provisions were applicable from November 2020. And in supporting these two documents, there is an additional document which I need to mention, which is Annex 6 Part 3, which talks about the helicopter operations from an operator's perspective. So these are the main documents. And I'm going to only touch upon quickly on the Annex 14 Volume 2 and a bit on the heliport manual, which we are going to talk extensively in this particular webinar. So most of you, I'm sure, will be aware of this particular document, Annex 14, Volume 2. So I don't need to talk extensively on this particular slide. So there are 6 chapters. First chapter is on general. We have on heliport data, physical characteristics, obstacle environment, visual aids, and heliport emergency plan. The one thing which I would like to highlight is over the years, especially focus has been on chapter 3, 4, 5, and 6, where there have been extensive changes which have been incorporated. So that this gives an indication that we would like to move along with the industry and provide good regulatory material as well as guidance material. In addition, there is also an appendix to this particular document, which talks about heliports, instrument heliports with non-precision and/or precision approaches and instrument departures. So this is in a nutshell. So if you look at the subsequent amendments, the idea of showing the slide is they're predominantly on the physical characteristics, obstacle environment, and visual aids. So moving on, what's new in the latest edition, that is the 5th edition, which was published in 2020, before we get on to the heliport manual. So there were several new definitions which were included in this particular amendment. For example, earlier we only had what is D, then we introduced what is design D, what is D value. So a lot of definitions were included in chapter 1 of Annex 14 volume 2, including what is a protection area, touchdown point circle, touchdown point marking, so on and so forth. So several new definitions were included in chapter 1. In addition, in chapter 2 on helicopter data, the main idea is to align this or make it similar to Annex 14 volume 1 on aerodromes. The need to publish RFF data was also included in this particular 5th edition of Annex 14 volume 2. And the other interesting thing which was included there in Annex 14 volume 2 is that earlier we had in Annex 14 as surface level heliports. It appeared that there was a bit of a confusion. I'm sure the experts can share it later on in having surface level heliports. So it included ground level as well as elevated heliports. So the endeavor is to make things simple, concise, and clear in Annex 14. That's why we moved on from surface level heliports to onshore heliports. The moment we changed that to onshore heliports, there were subsequent changes in the FATO and teal-off characteristics. Say things like FATO not to be solid was introduced. It need not be solid kind of a thing was introduced because we are talking about elevated heliports. So these were the major changes. So the new characteristics or amendments to the characteristics of FATO, teal-off were made much more clearer in this amendment of Annex 14 volume 2. And in addition, some provisions on helicopter routes, taxi routes, stands, and protection areas were also introduced in this particular edition. And on chapter 5, especially on visual aids, the requirement to have a D-value marking, which was a recommendation earlier with a should, was made to a standard. That was a major change because of the changes in the industry and the environment. And the most interesting thing to note is that a note was introduced under each marking and lighting provided in visual aids with an objective of why that particular marking or lighting is being provided. This gives a better understanding on how and why these kind of marking or lightings are to be used. This is a major change which was brought out. If you look at winch marking, if you look at D-value marking, for everything and every lighting, a note was introduced during this particular edition of Annex 14 volume 2. So that's something which was new. And again, because onshore heliports was introduced, we had to enhance the provisions on touchdown zone positioning marking. So this is not a comprehensive update on what was done. I'm just giving you a quick snapshot of the major changes which was done. So because it was an extensive and voluminous amendment which was included. Again, in chapter 6, there was a complete rewrite on provisions related to rescue and firefighting, which was introduced in this particular amendment. So these were the things which are available in Annex 14 volume 2, the 5th edition. Now, a quick sneak peek into the upcoming amendments. These are something which are at the matured stage of discussion. If everything goes well, this amendment 10 to Annex 14 volume 2, you may receive a state letter sometime by the end of this year or by the first quarter of next year on the upcoming amendments. So it's just a bit of a precursor for all of you of what's going to come. So the discussion is mainly on the certification and SMS of heliports. What's being looked at is the certification requirements for heliports used for international operation as a standard, and for other heliports, maybe you may call it as domestic ones, as a recommendation. So in line with this amendment, there is a proposal to amend Annex 19 also to include, because Annex 19 lists the stakeholders or agencies who need to have SMS implemented. Say, for example, the aerodrome operator, the ANSP, the aircraft operator, so on and so forth. In that, the heliport operators have also been included to mandate to have SMS for them. So these are the main changes which are coming up as far as certification SMS is concerned. This almost mirrors what is there in Annex 14 Volume 1 for aerodromes. The other major change which is being brought out is on the obstacle limitation surfaces. These surfaces have been kind of modified or extended to allow flexibility, because now we have more of helicopter operations in under high-rise areas and with obstacle-rich environments. So that is the reason why some of the things have been clarified in the heliport manual rather. That's why I'm just trying to, we may have discussions on that later on. So because the things have been moved and better clarifications have been provided, things have been made a bit more flexible in the SAPs on obstacle limitation surfaces. Also, for the PINS approach, in terms of protecting the vertical procedures with lateral component, the transition surface will be sufficient to protect these kind of things. These are some of the new things that have been which are being planned to be included in the upcoming amendments. As far as the visual aids are concerned, again, since some of the detailed material have been moved on to the heliport manual, the idea is, as I mentioned, is to make things a bit crisp and clearer in Annex 14 Volume 2, because it talks about standards and recommended practices. They've been made more objective as far as lighting systems are concerned. And a few notes have been included on the usage of night vision goggles for helicopter operators and their compatibility with the LED lighting that's been included. And again, some of the frangibility requirements, because the tail rotors are a bit fragile, based on a study conducted almost 20 years ago on the frangibility requirements. Instead of having those objects around the heliports to be frangible, the height restrictions have been included in this. So these are the things which are under consideration. The idea of sharing this is that to show the importance of looking into the guidance material, which is being provided as Doc 9261 in the Heliport manual. So quickly, what does the Heliport manual talk about? It was, in fact, initially published in 1995, when it was felt that there is a need to have more guidance material, and what is available in Annex 14 Volume 1 is not sufficient. So this was published almost 27 years ago. And now, and in 2022, rather, the fifth edition was published, sorry, 2021, last year it was published, the fifth edition. It consists of two parts. The offshore heliports is part 1, and the onshore heliports is part 2. We are going to have separate sessions about these two things, so I'm not going into the details. I leave it to the experts to talk about these things subsequently. And as I had already mentioned, I will not say Annex 14 Volume 2 provisions. The additional guidance or material which are available have been moved on to this heliport manual, so that to make things clearer and simpler in the SAPs for states and regulators to implement them. So these are the major changes, and and we are looking forward, as I mentioned, to continue this work and make things a bit more clear and concise for the industry and the regulators when it comes to heliport operations. So that's it from my side. I would look forward to keep interacting with you. Thank you.
Thank you very much, RC. Please now welcome Jim. Are you ready, Jim?
Yes, I'm here.
The floor is yours.
Can you see that, Fabio?
It's okay. I saw your presentation. You're ready now.
Okay, my name's Jim Lyons. I've been on ICAO working groups for a number of years now, more than 20, mostly on the operations group, but also on the Heliport design working group. And I just want to quickly take you through some of the history as I remember it as a working member of the group, not necessarily as a member of the ICAO Secretariat. Okay, the original intent of ICAO was to facilitate a system that would allow the transit of aircraft to and above all states in the world by providing a comprehensive set of aviation standards with which all signatory states could and would agree to comply. The stated scope of these standards will be international air transportation, and compliance will be built into an individual state's regulations. Clearly, having two standards, one for international and one for domestic, will be costly in terms of duplication and maintenance, and so it's generally accepted by most states that a single set of regulations will be applied throughout. The issue for helicopters, though, is that there is no widespread system of international air transport, mainly because of helicopter economics. That's high cost, limited range, and low capacity. Helicopter use is restricted to those niche activities where the unique characteristics outweigh the limitations and provide added value. For example, offshore operations, search and rescue, air ambulance, specific point-to-point transit, aerial work, etc. Some of these operations are possible because of the helicopter unique flying characteristics, and some because of the ability to operate to and from sites of very limited space. Almost none are directly related to international air transportation. Leaving aside the operational standards as facilitated by Annex 6 and concentrating on operating sites, Annex 14, the aim of ICAO is to provide a set of standards which protect in order of priority third parties, including persons and buildings, passengers and crew members. The aim is to provide heliports that can meet the highest standards for international operations, but could and should be applied to all. When providing the SARPs and facilitating text of the manual, the sites of the HDWG are clearly set, not just on international air transportation, but on heliports in the main.
Jim, I think you muted yourself.
Can you hear me now?
Yes, thank you. Sorry about that.
I don't know what happened to the microphone. Okay, so SARPs to meet these aspirations are better stated as objectives, that is performance-based rather than prescriptive requirements. That's apples and oranges. Most of the changes to the Annex over the past decade have been to facilitate this transformation. There is also a secondary reason for this change. In the past, there has been much and heated discussion in the HDWG over minimum dimensions as operations have moved from aerodromes to individual heliports, which are almost always limited in space and resources. Having SARPs written as objectives provides a clear statement of what has to be achieved and leaves little or no room for constant pressure to reduce the minimum dimension, for example, of the defined area, the TLOF, the FATO, the safety area, stand, taxiway, etc., or protection surfaces. The basis for the minimum dimensions, or even the raison d'etre of the defined areas, was established by the Heliops panel in the initial provision of helicopter SARPs in 1989, which were published in 1990. Unfortunately, all of the documentation, hard copies only, accidentally went missing when lost during a headquarters move of one of the organizations. The rationale, justification for, and history of decisions made is no longer available, and the original personnel have long since retired. The change from prescriptive to performance-based SARPs was based on a series of concept papers produced by and for the HWG. And these, in a sense, replaced the original documentation that had been lost. We actually reset the data. When changes to the SARPs were published for comment, it became clear from extensive comments that were received that the rationale for these changes was not clearly understood. Even though extensive justification was contained in the documentation, something more had to be done. The updating of Doc 9261, Heliport Manual, had been mooted for some time, but the decision on the authoring of the update had been put back several times because of contractual complication. Having published these changes, it was now clear that it had to be done very quickly, so the basis for the changes to the SARPs could be explained, and the manual developed into a more relevant guidance and methods of compliance. It was agreed that the revised manual would be provided by members of the HDWG. A first draft was produced within a 3-month period in 2019. The Heliport manual consists of 2 parts, one for offshore helidecks and the other for onshore heliports, both ground level and elevated. The offshore part was based on a UK CAA CAP 437, that's a civil aviation publication, called Standards for Offshore Helicopter Landing Area, a document that had been contributed to and was accepted by the international oil and gas producers as the de facto standard for helidecks. Now, the IOGP either own or charter all the helidecks that are used offshore. So it was important that they be part of this whole process. The onshore part was based upon the original Heliport manual, edited to reflect changes made to the SARPs, and importantly, including elements of the HDWG concept papers within a number of appendices. As the manual developed, more comprehensive guidance was included. The latest changes include sections on rotor downwash, licensing, safety management systems, elevation of the obstacle clearance surface, which is required more and more as heliports, particularly at hospitals, move into a more complex obstacle environment. The intent of the SARPs are explained and further developed in the guidance that's provided. Extensive examples meeting the objectives of the Annex are contained in appendices. The manual will continue to be developed and improved in the light of experience and further knowledge. And that's all I have. Thank you very much indeed.
Muchas gracias. Thank you very much, Jim, for your presentation. I hope that now the cameras thing is solved. So right now, I'm going to switch to Spanish.
Next, we will have our second session for today. It is about the work done by the working group on heliport design, what has been done and what is coming. For this particular session, let me introduce Arturo Madrigal. Arturo Madrigal is an aeronautical engineer with 22 years of experience in airports, airdromes, and heliports. He has extensive knowledge on certification matters, continuous oversight, SMS, and safety training. He's a consultant and head of SENASA's Airport Technical Assistance for the Spanish Aviation Safety Agency. He cooperates with ICAO as a rapporteur of the Heliport Design Working Group, HDWG. He is also a member of the Water Airdromes Working Group and member of the RPASP ADOP Joint Task Force, which has to do with RPAS or unmanned vehicles. He also cooperates with the GATS, the ICAO Global Aviation Training, in advanced SMS training. And finally, let me tell you that Arturo cooperates with EASA in the Vertiport Task Force, which is one of the presentations we will have at the end of this event. Arturo, are you ready? Yes, I am ready, Fabio. Thank you very much. Let me start sharing the screen. Can you see my screen? Yes, we can see your full screen. Thank you. So we are going to speak very quickly in the next 20 minutes about the HDWG, which is the Heliport Design Working Group of ICAO, what has been done, even though this has been very well described by RC, what we have done, and what is it that we are going to do in the future, what's coming. We are going to present the group. We will present the job card on which the group is taking action. We will look at the evolution of Annex 14 and the Heliport manual. We will describe the new requirements for certification and SMS for heliports. And after that, we will look at the future of this HDWG, including the design of heliports. Very briefly, the design group was formed. The Heliport Design Working Group was formed in 2005 as a study group with a mission of updating Annex 14, Volume 2, and the Heliport Manual. The industry was evolving drastically, and there was a gap between what had been regulated in Annex 14 and the guidance material provided in the Heliport Manual, and there was a need to make those two documents evolve at the same time. So this group is currently a very large group with over 20 active members, 6 persons who provide assistance between civil aviation authorities and people from the industry. So as you can see here, the Heliport Design Working Group is part of the Airdrome Design and Operations Panel, ADOP or ADOP. It is one of the 4 working groups. We have the working group on airdrome design, visual aids, airdrome operations. So the blue one, which is the group we belong, is the Heliport Design Working Group. And we have just created a specific subgroup for the study of vertiports that we will present later on this session. Very well then. How do the task forces in ICAO work within the airdrome panel? Since, well, the HDWG works based on a job card, which is a job card approved by the Air Navigation Commission. It was initially published in June 17 of 2015, 10 years after creating the working group. And the approval of the last change was in October of 2018. So that particular job card that was approved by the Air Navigation Commission for the work done by the HDWG is complete in 95%. And since it was created in 2015, it has significantly evolved as it is further studied and improved. The evolutions of the job card have been basically that we had to add new work package items that have been thought of, and some of the work packages within that job card have been delayed because of the pandemic, the COVID-19 pandemic, and in some cases because of the need of modifications or amendments of different annexes coincided with that timing. So whenever there's modification in the Heliport manual, we also need to make changes on this annex. What has the group been doing? What was considered in this job card? Well, they had to develop regulations for certifying heliports, including an SMS, safety management system. We had to review the item on lights of Chapter 5 because there has been significant technological development in terms of light. So we had to reflect that technological development in the regulation. We also had to look at the characteristics of the FADO surface, which has led to a full review of the characteristics of heliport surfaces. We also had to evolve on issues of rescue and firefighting services, RFFS. We also had to improve the markings of FADO and TLOF, and we also needed urgently to update the heliport manual as presented by RC and Jim Lyons. There was an urgent need of updating the manual due to a number of reasons. First of all, because it was a little bit old in terms of the evolution of heliports, and also because of the need of providing guidance on the huge progress made in Annex 14, Volume 2. If we didn't have an adequate heliport manual, we wouldn't be able to understand these new developments and changes. Well, Annex 14, Volume 2 has been presented by RC already. It has a scope. Well, it is divided into onshore heliports and offshore heliports. Onshore heliports include surface level or elevated heliports, and offshore include the heli decks, the shipboard heliports, and the winching areas. The chapters included in Volume 2 of the heliports, you already know which are they: heliport data, physical characteristics, obstacle environment, visual aids, and emergency response, and RFFS, rescue and firefighting services. These are the critical parts of the annex. Since the heliport design working group was created, as you know, 3 editions of the annex have come out. The third one in 2009, the fourth one in 2013, and the fifth one in 2020. So there has been a significant evolution of this Annex 14 Volume 2 from 2005 when the group was created until now. As you can see, the annex has changed completely. It doesn't look anything of what it looked like a few years ago. As I said, all the chapters have been fully changed and restructured. In terms of chapter 1, they have modified the applicability and the definitions. They have included the concept of designed helicopter. They have included the concept of a D-value. We have changed the structure of the annex. On helicopters, we have fully changed chapter 3 on physical characteristics. We have written in it based on the performance and the necessary characteristics of each part of the heliport, following the building block principle. Chapter 4 on obstacle environment has been fully changed. New surfaces based in performance have been designed, even though they have the same old mission of protecting helicopter operations. Now they allow for vertical operations of helicopters, and we have a number of surfaces that have been added. There has been a significant change on visual aids. There are new and improved markings and lights, and there have been significant changes in terms of lights, because as I said, there has been significant technological development in terms of light. They have, in chapter 3, they have introduced the need of having emergency plans, and they have multiplied the need of providing RFFS requirements in different ways in chapter 6. So Annex 14 Volume 2 has changed radically since the creation of the heliport design group. We are still embarked on the task of updating this document. Now we are going to talk briefly about a change on the SARPs of Annex 14, which is the change on certification and SMS. There is a significant change on the standards and recommended practices that affect each chapter. We've seen that Annex 14 has changed drastically, especially the characteristics of a heliport. And the introduction of certification and SMS entails a change that goes beyond this, because this is a change in the mindset, in the paradigm. This means that the heliport is going to move in a certified environment now. What have we done? Or how have we introduced regulations and standards for certification of airdromes with an SMS? What we have done is to introduce the same requirements of certification of heliports that we have for the certification of airdromes. That means that we are going to force to certify airdromes for international operations, and we will recommend to certify heliports open for public use. I repeat, we are obliging or forcing to certify heliports for international operations, and we are recommending to certify heliports open for public use, as in the case of Annex 14 and Volume 2 requires for airdromes. The certification would require to carry out the structure and operations of the heliport under a heliport manual and to include a SMS safety management system. The certification and this SMS requires to publish amendments to both Annex 14 and Annex 19. Annex 14, we need to oblige the certification of international heliports and recommend the certification of heliports open to public use. In Annex 19, we have to include heliports in the scope of the SMS. So both amendments have been presented, Annex 14 in the panel of airdromes of February and that of Annex 19 in the past safety management panel of December of 2021. And both amendments to the annexes have been approved in those two panels. So we have been able to move forward with the project of certification and SMS for the heliports. Now, we are going to certify heliports, but how many are we going to certify? Why are we going to certify them? It is great to certify them or not. Why are we certifying them? So, as indicated by RC on his first presentation, we have passengers that are going to fly in helicopters, and they were not protected by a certification, which was the helicopter certification, even though the air navigation service provider was certified, or the helicopter operator, and that non-certification of the passenger of a helicopter that is going to a heliport is different. I mean, the passenger who is going to fly in a certified helicopter to a heliport is flying to a non-certified heliport, whereas the passenger to aircraft is flying to a certified airport. So it didn't seem reasonable to have it that way. So we had to protect the passenger of the helicopter with a heliport certification procedure. At present, we might have very few heliports for international transport. There are many more open for public use, but the number of heliports is increasing. Additionally, in the future, we will have operations of VTOL, which are going to be similar to helicopters in the vertiports. That will be heliports for vertical operations, and they will benefit extensively from the certification and SMS of heliports. And after looking at the documentation existing on accidents and incidents at heliports, we have realized that most of the accidents of helicopters in heliports come from the non-compliance with the SARPs of Annex 14 Volume 2, the lack of adherence to procedures and industry best practices. And we also know that around 10% of helicopter accidents, both in Europe and in the US, involve potential deficiencies at the heliport. Around 10% of the accidents are produced at the heliport because of this type of deficiencies. We have mentioned lack of compliance with the SARPs and non-compliance with procedures or not following the best practices in the industry. So evidently, the certification will help us with all of this. It will help us to meet with the SARPs, and it will help us with the procedures we are already following. So hopefully we'll be able to significantly reduce these 10% of accidents. So this has justified the reason why we are going to introduce the certification and the SMS at the heliports, and we will now, well, we have talked about the past of the HDWG. We have modified fully Annex 14. We have written completely new guidance material on the heliport manual. We will introduce the certification of heliports. The certification has already been designed and it will be introduced into Annex 14 and in the heliport manual. And what is the HDWG is doing with a job card, which is 25% complete? Well, the HDWG will be left as the advisory group of ICAO on heliports, we will dedicate to analyze safety data, and we will update Annex 14 and the heliport manual as we gain more experience, or as we enhance our experience in the operation of heliports, okay? Another key task that we are focused on through this webinar, and that we will continue doing in the future, is to support ICAO in spreading all the progress made by the HDWG that have been reflected in the Heliport Manual and Annex 14, Volume 2. We will help to encourage the knowledge of these new regulations and standards to increase safety globally. Finally, we will initiate a process of certification of heliports, and ICAO will audit this heliport certification through the USOAP audit. The Heliport Design Group will support ICAO during these audits. And now we have one of the more trendy issues. There's going to be a slight variation, which is the vertical and electrical variation, the new drones for transport of passengers and goods that will operate from specially dedicated vertiports, and they have just created a vertiport design subgroup, BDSG, within the HDWG. As I said, vertical aviation is evolving very rapidly. The manufacturers of VTOL, electrical VTOL aircraft, have begun certifying the aircraft with the European agency and the FAA. So the manufacturers expect that the certification of aircraft will be completed in 2024, 2025, in a couple of years or 3 years. They expect to initiate operations with eVTOL vehicles. They initially expect to operate vertical aircraft, which are both manned vehicles and BFR. So in addition to this operation, so they can fly in the airspace as with any other aircraft, there are also going to be commercial operations, and different investors are thinking about establishing chains of communication through these aircraft to connect vertiports within the cities, to connect one city with another city in mid-distance routes, and also to communicate the airports with the downtown or the central part of the city. So this commercial activity is going to start developing in 2024, 2025. These operations that will initially be manned and visual, in the future, they might evolve to vertical operations, remotely piloted, or a mix of both. These aircraft are going to use heliports, vertiports, which are going to be especially designated areas for them. So evidently, we need to have a vertiport regulation. We will talk more about vertiports at the end of this sessions. You should know that EASA has created a draft that is published in their website, and this is a prototype. It is not a regulation completed, but it is just a prototype for the use of the state. And if you wish to visit EASA's website, you can download this technical standard. And the FAA has also produced a draft on design of vertiports. This is the engineering brief, EB and 105 vertiport design. EASA and FAA have begun cooperation, so the vertiport standard that comes out from the Federal Aviation Administration and EASA are similar. So what has ICAO done? Within the Heliport Design Working Group, and upon request of the previous rapporteur of the group, Kevin Bain, well, they have created a vertiport design subgroup that was presented in meeting 4 of the ADOP Airdrome Design and Operations panel, and it has been approved by this panel. So hopefully this vertical design subgroup will have a job card approved by the Air Navigation Commission by the end of the year. We have presented the BDSG presented at HDWG 16 meeting with a broad participation of the industry, and the NAAS. And the objective of this group is to create SARPs, standards and recommended practices and guidance material for VTOL operations at vertiports, heliports, and airdromes. The horizon, there you have it, 2024, 2025. We should aim for when these aircraft start their operation, and we will have to do it in coordination with the FAA, EASA, and other ICAO groups. And the participation of the industry and the industry associations is of the essence because they are the ones creating this new type of aviation. Okay, so this is the end of my presentation on the HDWG. What have we done and what's coming next? Thank you very much. And I hope I didn't go beyond my time. Thank you very much, Fabio. No, on the contrary, Arturo, thank you very much for such an interesting presentation. It's good to know that you are working jointly with the FAA and EASA, who are the main stakeholders and players on this process to make sure that ICAO can present to the states a harmonized product. Very interesting presentation. Thank you very much, Arturo. Now I am going to switch into English to introduce our next panelist.
All right, thanks again, Arturo. Now we are going forward with the next presentation. It's a brief introduction to offshore. Now I have the honor to John Parker. Mr. John Parker is an electrical and avionics engineer and quality and safety manager with 35 years plus of experience. I don't know what the plus means, John, in aviation, mainly within offshore helicopter operations. He serves as the Offshore Helideck Work Group co-chair, representing IOGP, which I already mentioned, and IOGP Helideck Working Group lead, and ICAO Heliports Design Working Group member, representing the International Oil and Gas Association. And he currently serves as the Safety and Operational Risk Assurance Aviation Authority for BP Limited. So John, are you ready now?
Por favor, sir, please, we ask you to please speak slowly for us. Thank you.
You hear her?
Yes. So my apologies, first of all, Fabio, my video is on my laptop. I can't get my main video to work. So I say hello to everyone and switch it off because I'm looking to two different screens.
Great.
So yes, so let me just share my screen to make sure I've got that. Which should be that, hopefully. To share. So hopefully you can see my screen.
Yes.
Yeah.
You're ready.
And then my next trick is to switch this video off. Do 1 second. Let's make sure I get that right. Maybe not.
It's still on.
Not video. Right. We're good
Now,
to go.
yes.
Okay. Right. So first of all, thank you. So thank you for the introduction, Fabio. As probably some of you know, Kevin Payne was originally scheduled to do this presentation. Unfortunately, he's on leave, I think, this week, if I remember rightly, or has a clash. So I'm here as part of the Helideck work group for ICAO. I'm part of that as the IOGP member there, representing the oil and gas companies. But I also represent Heli Offshore now, which is the helicopter operators part in the group. So without ado, I'll say thanks again to RC and Jim, who have done a great job in setting the scene there with the regulation. And I won't spend too much time going over that. So I'm going to concentrate on the 9261 document part 1, which is the offshore part of the heliport manual. Hopefully we should be able to just go to the next screen. Why is this not moving? Bear with me. Decided not to let me change screens. Sorry about that, guys. I just lost the presentation for a second. Okay, so hopefully you can all still see that. So yes, so again, as I said, so we're going to concentrate on what was the migration. So we've had originally the 9261 Heliport manual was released, and at the 4th edition, that was only the offshore heliport manual. As Jim and RC have just explained, the 5th edition has now been released with the onshore part. So for the piece of that, the offshore part was published as 4th edition back in January 2020. And as I say, the 5th, which included the onshore. So moving on, so I'll focus on the chapters in general, and all I'm doing is providing you with an overview, excuse me, of the chapters, and I've lost my page again. I need to go back. Sorry about that. So chapter 1 of the Heliport manual for offshore is basically the scope of the document and outlines what is covered by this document in respect to purpose-built helidecks on offshore installations and vessels, and with any specific specialities as regards to non-purpose-built shipside arrangements. It also is called links to the ICS helicopter ship guide in 2021 to focus on the characteristics of common helicopter types. Chapter 2 is basically a template for the authorization of offshore heliports and covers the context of any helideck directory, or what we would know as the helideck landing limitations, the HLL. And for some of you guys in the authority, you'll understand what a helideck information plate is. Some of these are produced by the inspection authorities, others are produced by the helicopter operators. So chapter 3 is a focus on the physical characteristics and includes guidance on structural design and the general design considerations for a helideck. Now, this would include things like turbulence, temperature rise, and any special considerations for floating facilities. So in that case, we're talking about where we do fluid dynamics checking, etc., for anything that may impact a helicopter approach to a helideck, and also for the pitch, roll and heave. Again, my apologies because I'm getting a bit too keen with my too keen with the pointer there. So above and beyond that, we also cover the minimum standard for the FATO and the tail off for 1D of a helicopter. And in that, where we can reduce that to less than 0.3D for any helicopter that is designed under CS27 or sits below the 3,175 kilogram limit. There is a process in place where we may remove that in the future, but regardless, we will take advantage of the sub 1D risk assessment process, which is detailed in Appendix 1 of the document. That appendix is simply a risk assessment process which facilitates operations to helidecks where the tail off is less than 1D, provided that we meet certain conditions. The process itself is pretty simple. A new helicopter type introduced, which is slightly longer than the original design helicopter, is replacing, for example, the design for an S76 with a diameter of 16 feet, excuse me, is intended to be a replacement by a 139 of 16.63. Again, I've done it again. I need to stop clicking. So The other element is that the helideck surface arrangements are included in Appendix 1, which is in the main for the drainage capacity check and calculation of a helideck to ensure that there's no standing water, or in respect to firefighting, where we have leakage of fuel, for example, from an incident with a helicopter on the deck, there is capacity for that to drain. Chapter 4 covers the obstacle environment in its own right and describes the surface for the helideck and also for shipboard heliports. Any temporary combined operations, what we would look for multiple platform configurations, what we require as far as obstacle protected surfaces for square as opposed to circular decks, and then lastly, the mapping of obstacles on the non-purpose built shipboard heliports based on what I've already mentioned in the ICS helicopter ship guide. Chapter 5 is where it gets a bit meatier. And so for chapter 5, we focus on visual aids and primarily marking and lighting of the helideck. The identification of the maximum permissible T value and D value, the perimeter of the helideck, touchdown positioning circle, and obstacle-free sector, including the prohibited markings and the installation names. Noting that all of these markings are expressed both in metric and imperial units, depending on which country of operation the helideck is in. For helideck lighting, it's still permitted to use the teal-off lighting solution that utilises floodlights. However, we have a new Appendix 1B, which has been developed to cover the specification for helideck perimeter lights, a lit touchdown perimeter circle, and the lit heliport identification H marking. This is probably more commonly known in the industry now as the circle and H lighting system, which is now becoming much more common across the world and is being seen to substitute or negate the need for flood lighting. There is also a basic lighting system specified for the non-purpose ship-built heliports. Okay, so moving on to chapter 6, that is where we focus on helideck rescue and firefighting facilities. So there is a new scheme that acknowledges that there are several different methods of distribution on both solid plate and passive fire retarding surfaces. These methods of primary media distribution include fixed monitor systems, FMS, deck integrated firefighting systems, DIFs, ring main systems, RMS, and also DIFs using compressed air foam solutions. A passive fire retarding system may utilize water only in lieu of foam, and the foam application rates depend on whether a type B or C foam concentrate is used. Discharge duration where a passive surface is used is reduced from 5 to 3 minutes in this case. So I haven't got a slide here on this, but basically the passive deck is where we have a drainage system that removes any of the fuel that could fire an onboard helideck fire during an accident or incident. A special section has been created for the not permanently attended installations. In the oil and gas industry, we call that normally unattended installations, hence my confusion. This basically specifies automated diffs or seawater diffs with a combination of a passive surface. Personnel levels may be determined using a task resource analysis tool. But typically, we'd expect all personnel to have basic training and obviously employ PPE standards. And the last part is that we have a provision for emergency response procedures. Those emergency response procedures would be one, directly for the offshore installation or the vessel, and secondly, for any link to the helicopter operator that would be operating to and from that installation. Chapter 7 covers winching areas to ships, and there is guidance on the location, any physical characteristics, and specifically any obstacle protection. It includes marking of the winching area and lighting, particularly for use during night or hoist operations. Chapter 8 covers anything in the miscellaneous bracket. This has been introduced the first time, mainly because a lot of the larger offshore installations nowadays have criteria for parking areas and for push-in areas to allow a second helicopter to land, for example, offshore. It also covers the weather equipment and basic guidance on any helideck motion and the reporting and recording of this. In addition, we include communications and navigation equipment, helicopter refueling operations, and again, bird control, which, although that is part of the main helideck, is also a specific issue when we come to those normally unattended, unmanned installations. So, in summary, that was the complete of the part 1 of the offshore. What I'd like to do is just take another 5 minutes to quickly go over the IOGP and offshore helideck work groups that have contributed to the ICAO helideck work group, and just outline some of the information we have available. So both these work groups are a collaborative effort, and that is where both the offshore helicopter operators and the offshore energy industry linked to ICAO's helideck work group. The focus is on improving safety, sharing lessons learned, and development of processes, people, and technology. The slide you can see just now is from the incidents and accidents that we've recorded during the period from 2016 to 2020 that we've used to focus our attention on areas for improvement, specifically on safety matters. As you can see from that slide, a lot of the issues have been towards procedural and process issues, but thereafter it comes down into specifics about equipment installation serviceability, poor communications, manifests, FOD, etc. So a lot of this may or may not be directly linked to the design of the heliport, helideck. The 5 main areas that the helideck work groups have been focusing on have been helideck equipment serviceability and maintenance, helicopter fuel and fuel control, passenger and baggage handling. That would also include cargo, by the way. Communications, by that would be communications between the offshore facility and direct with the helicopter, prior to departure and on approach and departure from the offshore installation. And lastly, helideck team training and competence. So part of the work group, we've put together some videos, which I'm not going to show you today. I've provided the links here for the audience to look at in their own time. They're both available through YouTube by these links. One is specifically on helideck management and the role of the HLO, etc., in communicating to the helicopter. And the second one is about the downdraft dangers in and around a helideck caused by a helicopter. In the place of Heli Offshore, we've created a helideck info share system. So that this is a method of reporting anonymously or otherwise to the group issues we've seen in and around helidecks. So this can be done by the helicopter operator or by the offshore installation themselves. At the moment, we're still in the throes of introducing this fully. It is in operation and the helicopter operators have bought into this. We've not got so many from the offshore installations themselves. Mainly, there is a protocol in place and we have loaded some historical helideck occurrences to give a flavour for what we're trying to achieve. There has been training provided for those gatekeepers involved in de-identifying the information we share with industry. And basically what we're trying to do is avoid any duplication of effort, make sure that everyone is aware of these type of incidents, and lastly, how can we focus on the learnings from the occurrences? A further initiative that Heli Offshore and IOG have been working on is the helideck equipment serviceability and maintenance. So it's great that we have a helideck that is designed to meet the ICAO Annex 14 Vol 2 9261 guidance document, CAT 437, Norman 27 for Brazil, etc. But what we're finding is that we need to be sure that this equipment is being maintained appropriately, but more importantly, if there is a problem with any of the helideck equipment, that it is reported to the helicopter operator, so as they're aware of any problems prior to flight. That doesn't necessarily mean that the helideck is closed. It may still be able to be operated safely with certain contingencies in place. So this came and was born out of the data that we analysed that I mentioned earlier in the graph, and highlighted that there was a weakness there. So the MMHL is a categorised list which provides equipment and systems that may be temporarily inoperative for safe operation. This would apply to both manned or unmanned installation. So it's highlighted through the Heli Offshore Safety Performance Model and highlights where we have helideck and heliport design, but covers things like pitch, roll and heave for vessels, heliport management itself, number of aircraft that we can have on the helideck, etc. So really the focus there is maintaining the original design as a minimum, and by that making sure that the helideck equipment is maintained serviceable throughout the period of its life. This is just a snapshot sample page from this MMHL. So I won't go into any detail. Again, there is guidance that will be available through the link that I'm going to provide on the next slide, I hope. But I'll just give a pause for a second here. A good example of this would be the circle and H lighting, all the floodlights. So if this lighting was not working on any given day at the offshore installation or vessel. That doesn't necessarily mean that the helideck is closed for operations, provided any helicopter operations were in daylight hours with reasonably good visibility. What it would do is put a restriction on operating at night. So again, this is just to highlight an example of that. So the MHL document has been released for guidance through Heli Offshore and is basically the outcome of around 24 months of work between the Helideck work group, which includes members from various helicopter operators, from the offshore oil and gas companies, and from one or two of the helideck inspectors we have and inspection companies around the world. So there is a link there direct to this document, and that document is available free to anyone who wishes to download it. And that's me, I'm done. And again, apologies if I'm running over time.
Thanks a lot. Thanks very much, John. It's a very interesting approach, and thank you for sharing all those resources. As I mentioned before, all the presentations will be available at our website. So they there you will be able to check all the links that John kindly shared with us. Again, thanks, John. Moving forward with the next presentation, please, I will like to remind all participants that we'll have a quick question session at the end. And also you have the option to raise any questions through the Q&A option in the toolbar below. So going to the next presentation, we'll have Jim again, now with a brief introduction to the part 2, which is onshore heliports. Jim, are you ready?
Yes, I'm just trying to find my presentation. Just bear with me for a second.
Yes. After Jim's presentation, we'll have a quick break just to get some coffee, go to the toilet, etc. And then we will come back with the last sessions on the state experience and also the Vertiports and the Q&A session, okay?
For some reason or other, I can't find my presentation, even though I've got it on my screen. I might just have to share my screen.
Okay.
Can you share can you see my screen?
Yes, it's showing right now.
Okay.
But the whole, there you go. Now I see the PowerPoint. There you go. You're all set.
Okay, what I'm going to do now is I'm going to cover, first of all, I'm going to try and speak slower. Otherwise, I'll get a slap on the wrist from the interpreter again. But what I'm trying to do is I'm trying to give you a quick gallop through part 2, which is the onshore heliport manual. Now, you've got to understand that John represents an organization that not only owns all the helidecks, but contracts all the flying to them. So it's not easy, but they've got good control of what goes on. Now, unlike offshore, onshore heliports are not the same. There's a proliferation, there are thousands worldwide, and there is very little control. The Annex 14 provides some control, and with the certification and the SMS systems that Arturo talked about, that control will improve as well. And so I don't expect anybody to remember the slides, but every slide that I have here represents something that's in the manual. So if you open the manual, you should be reminded of what you're seeing in the presentation. So it's Doc 9261, it's the 5th edition, and it's part 2. The Heliport manual, the contents mirror exactly the contents of the Annex 14 Volume 2 format. So each of the chapters mirrors the chapters of the Annex. The chapter 1 we've already talked about in the presentation earlier. RC and myself covered the introduction, scope, and the contents of the document. So if I go to chapter 2, the couple of points I want to make about chapter 2. There aren't many pictures in it. It's nearly all narrative. But the things that are missing are the certification of heliports and the safety management systems, both of which are written and both of which will be incorporated in the manual at the next revision. The inspection, qualification, and training is just a placeholder at the moment. That will be completed and eventually added to the system as well. So in chapter 2, we have site selection, heliport data. These two sections will be put in the next revision: heliport winterization, safeguarding of heliports, which we talk about, but actually requires a certification to be able to implement the safeguarding of heliports. Chapter 3 are the physical characteristics. And in particular, there are the FATO, the TLOF, helicopter taxiways and taxi routes, aprons and stands. Now, in my last talk, I talked about the notes to the meeting of the HeliOps panel going missing, and consequently, a whole bunch of concept papers were produced. Now, those concept papers have been partially turned into a number of appendices which are contained in chapter 3. Those appendices aren't directly associated with heliport design, except that they explain the rationale for the decisions that have been taken over the last 10 years. And they explain to those people who don't understand the issues, some of the issues that are covered in the appendices. So as far as the physical characteristics are concerned, I want to make a point about what it actually contains. And what we're really talking about are the objectives, the attributes, and the associations. And for each of those defined areas on the left, the FATO, the TLOF, the stand, the taxiway, the ground taxi and air taxi route, for each one of those, there will be an objective, an attributes, associations. And each one of these forms a building block. And that building block can be put onto a heliport, and with a certain assurance that it doesn't matter if the boundaries touch, there will still be a safe margin between each of these defined areas. So here's an example. This comes from Annex 14, Part 2, and it's the text that contains the objective. The whole of this is the objective. Then you have the attributes. This one's containment. This one's the surface conditions. And lastly, you have the associations. Each of the defined areas will have something very similar to this inside the annex. So let's look at some of the things that are inside the inside the manual. And I have to say there are 150 figures in the manual and something like 20 to 30 tables. So it's a visual document. And when we were producing the manual, what we tried to do is try to produce a description, a pictorial description for everything we were describing in the narrative. So here we have a FATO with a TLOF. Here we have a FATO with an aiming point. Now, I've already seen some of the other presentations, and I know that it is not a standard worldwide that the touchdown positioning circle, which is this yellow circle, which is part of the touchdown positioning markers, are not contained on a lot of heliports. They have this triangle. In the annex and in the manual, that triangle represents an aiming point, and that FATO is not intended for landing. Only this FATO is intended for landing. The minimum FATO size is 1.5 design D, and I'll talk a little bit more about design D a little bit later. Here we have a PC1 FATO with a rejected takeoff area, and 2 more PC1 restricted or short filled and helipad. Now, with respect to this one here, the FATO does not have to have a surface. And in the annex now, the FATO is an area which has an attribute of containment and doesn't necessarily have to have a surface. So if this was an elevated heliport, this dotted area would be in space. Some of the associations, one of the associations is a side slope. So each heliport should have a side slope, which is at 45 degrees to 10 meters. And here inside we have pictorials of how those side slopes should appear for various configurations of heliports and their takeoff approach surfaces. The dark green is the standard and the blue is a recommendation. So it's recommended that we have them on both sides, but the standard is having them on one. Another physical association is a PC1 backup area. So if a PC1 helicopter is doing a backup procedure for a short field procedure or any vertical procedure, these are the elements that we expect to see in the backup area. It's an ascent-descent gradient. There's a obstacle limitation surface, and one emanates from the center and the other one emanates from the safety area. And the 3D representation of that is as follows. So the blue area is the ascent-descent surface. The helicopter goes up there and comes down there. Here we have 3 helicopters represented as their D values at their TDPs. And down here we have the FATO and the safety area. Moving on to the TLOF, exactly the same again. The TLOF has an objective which is set out in the boxed area. It also has the attribute. This one is for containment. This one is for surface area. And it also has an association. And I hope you can see at this point. On my screen, I have a block here, so hopefully you can see what this says. So the TLOF is always associated with a FATO or a stand. So if you have a FATO, it might have a TLOF and it might have an aiming area. But if you've got a TLOF, it will always be associated with a FATO or with a stand. Taxiways and taxi routes, the taxi attributes, containment for the wheels and surface loading. Taxi route attributes are containment. It doesn't have a surface loading requirement. And here we have a taxi route with a ground taxiway, which is 1.5 times the largest overall width, and a taxiway, which is 2 undercarriage widths. The taxiway is always associated with a taxi route, either ground or air. You can't have a taxiway without a taxi route. On the other hand, you can have an air taxi route without a taxiway. So here we have an air taxi route with a taxiway, and this one you don't have a taxiway at all. Okay, so moving on to stand. The stand attribute is containment. Although there may be a surface, the surface is described in the text, and it doesn't necessarily have to have a surface area. The stand is always associated with TLOF, which provides wheel containment and surface loading attributes. So the stand itself has containment, that's this area here, the gray area. This is the protection area. The TLOF is in the middle. This is an air taxi route, and this aircraft is taxiing in and landing on the TLOF inside the stand. And there are 3 of them there. Here's a more complex stand, and this is for ground taxiing. So we have the taxiway, the ground taxi route, going into a stand with an entrance at either side. And the reason we have this elongated section, those of you who are pilots will know that you have to move the aircraft slightly in the direction to pull on the wheel locks. So there's always a little space required here for the wheel locks to be put on and taken off. In chapter 3, Appendix A, this is one of the conceptual documents that I was talking about. In order to define the critical design helicopter, the following elements have to be established. Now, the design helicopter is a virtual helicopter containing all of the most demanding requirements from all of the helicopters. So if you've got a population of helicopters going to a heliport, that population of helicopters will have, each of them will have different attributes. The worst attributes of all will be contained in the design helicopter. And that design helicopter then provides the limitations that are contained on the heliport. So the first 2 basic ones, the maximum takeoff mass or the weight, and the largest dimension of the helicopter with the rotors turning. These are 2 that are marked on the heliport, and when they're marked there, they're indicating that that is the maximum size and the maximum mass that that can take. The rest of them, the largest width, the largest undercarriage width, the largest containment area, the largest distance between the rotor centroid and the midpoint, the dimensions for the hover, and if applicable, ground turning, the wheel skid loading to establish the surface loading requirements, the fuselage length width for the RFS calculations, and the critical obstacle avoidance criteria for the obstacle limitation surfaces all have to be contained in the design helicopter. Once that is established, the designer then gets on and designs a helicopter. All of these should be defined before the designer moves to the detailed design. I'd like to just cover 2 of these elements that are discussed in the paper. And the paper is a conceptual paper, so we'll discuss each of these in the concept of heliport. So if you go to the manual and you pick up Appendix A to Chapter 3, you'll find that there is a whole conceptual paper which talks about all of these. So I briefly want to cover the largest containment area for all undercarriages and the required dimensions for hover and, if applicable, ground turning. First of all, I just want to briefly discuss how we arrive at the minimum dimensions of a TLOF. So if you look at this aircraft here, we have a 76 and a 139. One of the things we have to do is we have to establish the total width required for that aircraft to be situated on a heliport in any direction. So in fact, this is a circle, but represented as a line, and we have 2 directions rather than 360. So the 76 is one of the most demanding aircraft. It has a long base here that is required. Now, an aircraft can only be accurately placed on that if the pilot sits on the touchdown positioning marker. Now, because the pilot is, in theory, 0.25 back from the front or 0.75 from the back, that's how the touchdown positioning marker works. If in fact he's not 0.25 back, there's an error, and that error is accounted for in the TLOF minimum size. The other error is that the pilot in setting down is always going to make errors of positioning, particularly with a circle. It's extremely difficult. As I mean, I have a large number of hours offshore, always flying to the circle. And I can tell you, it's very difficult to put your bum on the touchdown positioning marker. And so there will always be errors of positioning. Now, this area here, plus the geometry area, the pilot, plus the positioning error, is added to the most demanding area here, and we arrive at the 0.83D, which is the minimum size for all TLOF. So in the paper, it goes, in the appendix, it goes through and describes all of that. So 0.83 arises from those principles that I've just mentioned. Now for the turning, I'll leave the turning in the hover, because that's one issue, and just address the turning on the ground, which is also discussed in the appendix. If you have a radius of turn of 0.25D, you have a circle of 1.25D, or you require a circle. And that's a very, very tight turning circle. If you have a radius of turn of 0.5D, you require a 1.5D circle. But in practice, most wheeled helicopters have a minimum radius of turn established by the manufacturer, which should be used in the design process. In the absence of data, the minimum radius of turn should be 0.5D. Moving on to Appendix B and surface loading. Now, the surface loading addressed in two areas: static, which means that the helicopter has no motion, it's at rest or quiescent, and that is static loading, or dynamic loading, which is of or relating to energy or objects in motion. Now, the appendix discusses all of these issues with respect to certification, non-normal landings, emergency landings, and so on. It's all discussed, and it comes up with a series of recommendations. It also contains the FAA guidance, which is rather more simplistic, and which gives two figures, one for static and one for dynamic. And I have to say that for an elevated heliport, the same as an elevated helideck, there are a number of calculations that are required to be done to establish the dynamic loading, and all of the discussion of that is contained in Appendix B. Appendix C, which is another technical appendix, is addressed at the rejected takeoff distance vis-a-vis the TLOF and FATO. Now, manufacturers have always tried to squeeze the dimensions that they require in the RFM down as low as possible to be as competitive as possible. And when it comes to the helidecks or elevated heliports or helipads at the surface level, they only ever produce a minimum surface required, and that surface required doesn't address the TLOF. So this appendix shows you what has to be done to establish the TLOF, which is this TLOF size here. I'm not going to go through this particular appendix. You'll have to read the appendix to understand exactly what it does. And this area here establishes the minimum FATO size. Appendix D is another appendix in Chapter 3, which establishes the virtual clearway outside a heliport. Now, we looked at the backup procedure, and the backup procedure for a performance class 1, a category A procedure, all category A vertical procedures other than runway type, so that's short field, restricted area, vertical or backup, require a clearway. It's either within or outside the heliport boundary. This is an example of one that's either inside or outside the boundary. If it's outside the boundary, it's virtual. If it's inside, it's part of the defined area. And from that, you established the min dip of the procedure, which is the lowest point that the helicopter reaches if it loses an engine, and the takeoff distance required, which is the VTOL on a rate of climb. This is appended the obstacle limitation surface, the takeoff climb surface, which is at 4.5%. You have exactly the same thing if there are obstacles. You establish a virtual clearway above the obstacles. And those of you who fly and look at flight manuals will recognize this picture, but may not recognize the clearway that's required here. And once again, the aircraft dips down, keeping 35 feet, 10.7 meters between the aircraft and the obstacles, moves up to the takeoff distance required, and then the OLS kicks in. So the aircraft is always 35 feet above the OLS when it reaches the initiation point, the origin. And here's another one showing an elevated heliport with the virtual clearway above all obstacles and all the other elements inscribed there. Here's a 3D representation without the obstacles. Once again, with the ascent descent surface, the obstacle limitation surface, the FATO safety area, the helicopters in their TDPs, the clearway, and the obstacle limitation service, the departure service. And the aircraft dips down along the clearway and then starts its climb at this surface here. Now that may look a long surface to you, but I can assure you that these aircraft do take a while to reach the min dip. And we have another appendix, Appendix E, which is not yet in the part 2, the onshore manual, but will be. It's already been passed through the HDWG and will be incorporated in the next revision. And this mainly addresses rotorcraft downwash and outwash. Now, in this pictorial representation, and this is an actual trial of a blade and so on, you'll see that the downwash and outwash, mainly the downwash, has several components. You have these shear surfaces here. You have these vortices which come off the blade tips, which migrate down and then along. And remember, you get one of these for every time the blade passes that surface, you'll get one of these formed. So you get one form for every blade rotation. And if you've got 5 blades, you'll get 5 for every rotation of the disc. And this is a very, very complex area. And because recently we've had a number of incidents and accidents, we now require to put something in the heliport manual. So if we look at another pictorial, and this one's closer to the ground, it becomes even more complex because these vortices start pairing. And this whole area here becomes complex when it gets closer to the ground. So in pictorial terms, here's an aircraft that's hovering. It's hovering up here. It's requiring a force to hover. That force produces a velocity through the disc. And because the surface narrows here, you get the preservation of energy means that speed there goes to 2 VI. So you have a velocity of airflow, an induced velocity, and at this point here, within 2 diameters of this point, you get a 2 VI, which is 2 induced velocity. And this is represented in the manual as in tabular form. And inside here, you've got the critical areas, which are the mass, rotor diameter, rotor area, disc loading, air density, and produces a table of speeds. And if you take, for example, a V-22, the Osprey, 2VI is 75 knots. For a 76, it's 48 knots or 88 kilometers or 25 meters per second. But we're also interested in this outwash area here. And because the air squeezes down as it interacts with the ground, there's a narrowing here. And once again, conservation of energy means that at this point, you're likely to see 3 induced velocities. And you're also likely to see a confused area where the vortices start to interfere with this here. So it's not a laminar flow as is sometimes depicted. It is a very confused area. And so what we've done is we've used the FAA model called the ROFOOT model, which is based on a whole bunch of trials done in the US a number of years ago and has been validated by aircraft trials. And inside the manual is a table, and it gives you a radius at where these speeds reach. And this radius is here and meters here. So this is 20 meters per second, 15 meters per second, and 10 meters per second. And these are the safe range. This is the safe range at which the boundary should be situated. And so this leads to a condition where you can establish a boundary at a ground level heliport that is safe from outwash. And bearing in mind that a lot of these heliports now are hospitals, and they're close to the areas where the aged and the infirm move towards the hospital, it is a requirement. And there have been some deaths recently caused by the outwash. Okay, that concludes the characteristics. Moving on to the obstacle environment. The obstacle limitation surfaces and sectors deals with the approach surface, the transitional surface, the takeoff surface, and inside the manual, surface with and without pins, which has been put in for information. And there's also an appendix at the end dealing with elevating the origin of takeoff and approach surfaces and utilizing PC1 vertical procedures. Inside the manual, there's a table that contains the required surfaces and dimensions for any obstacle limitation surface, but each, in accordance with the notes, can be modified by elevating the surfaces when vertical procedures are in place. So we have 3 types: a type A, a type B, and a type C. The specific case of elevating the clearway OLS and protection surfaces is addressed in Appendix A, but is discussed in some of these notes that are in the table. Here we have an approach surface, and almost inevitably an approach surface will be type C, which is a 12.5% a surface, 8 in 1. And the diagram sets out the display. This looks like a coffin, but in fact it's not. These are parallel surfaces. That's just a perspective to the outer edge, a height at the outer edge, and a length of the obstacle limitation surface. Also in the manual, we discuss the transitional surface, and there's a discourse on the transitional surface. And this shows it, and it's used mainly for limited visibility procedures, so that when an aircraft's coming in, if you get temporarily displaced because the visibility is low, he's protected from the obstacle. Then we have a takeoff climb surface, and this is a type A. And the type A surface is a 4.5% surface. That's a 2.6 degree obstacle limitation surface. And you have the same dimensions here that are discussed in the manual. But importantly, it's not possible to have a performance class 1 procedure without a clearway. And the normal presentation would be for there to be a clearway, whether elevated or ground level, and the OLS appended to that clearway just here. A type B surface, which is got a lower gradient than the 12.5, and then a steeper gradient here. And this area is meant to accommodate for singles or twins without very much performance to get to their climb speed before they hit this gradient here. There's a takeoff climb surface for performance class C, which we've seen on the approach surface. It's an identical surface. Chapter 4 also has inside a discussion of pins procedures and a proceed visually with a DP. Now, a DP means that when you get to the missed approach procedure, you proceed horizontally to the decision point, and then you proceed visually to the heliport. And to make this easier to understand, we put a 3D depiction in the heliport manual, so you can correlate one with the other, and you can see exactly what it looks like when you see these surfaces. We also have one without the DP, where you reach the missed approach point and then proceed visually, and a 3D depiction of that as well. Now, Appendix A, elevating of the takeoff surface, is a complex appendix which requires to be read and understood. And it addresses areas which we're seeing more and more of. And what we're seeing is heliports in obstacle-rich environments where the obstacle limitation surface of 4.5% is not possible from the just here, because the obstacle, there is no clear area for them to get out. They're usually in congested areas. And so you end up with this configuration here. And we've seen this before: obstacle limitation surface, ascent, descent, clearway, elevated OLS. And what happens is you have to design this so that the takeoff climb surface here clears the obstacle, and the clearway is established here, and then the designer puts the clearway into the information, the airport information, and this is how you arrive at the elevation. And with departure, the same, you arrive in here and you depart down this surface, and it can be, the designer probably has a tool like this to work out the 12.5% surface with the obstacle limitation surface, the backup surface, and the ascent descent surface. So the approach is here to this surface and then down. And also inside the appendix, we have transitional surfaces that protect the helicopter for those helicopters that have a lateral element in their backup, or they have a sideways. And these transitional surfaces are an extension of the protection surface we saw as an association in chapter 3. So the side slope protection is extended up into this transitional surface. The clearway is widened and then is appended to the takeoff here, and so on. And this is the most complex of the drawings that's in there, because it deals with both the approach and the departure, and it's all in Appendix A. Moving on to chapter 5, the visual aids. It deals with indicators, marking aids, lights, and there are 3 appendices which are basically methods of compliance. So indicators are these here, and onto the marking aids. Here we have a marking aid for a TLOF. We have the perimeter markings, the heliport identification marking, the maximum allowance mass marking, and the D-value marking. And the D-value marking, this marking here, defines the D-value or limited size, not the TLOF or FATO dimensions. So this is not the size of either the TLOF or the FATO, it is the D-value. So the pilot knows that if his D is within the 18 meters, then he's clear to land at that heliport. And here we have some markers and lights for runway type. Here we have the visual aids for aiming point with the FATO marking, the aiming point marking, the identification marking, the mass, and the D value again. Here we have visual aids for stand markings with the taxi route and lead-in lines, comprehensively marked. For visual aids, we have pictures of all the lights, and we have in this particular one, there's the touchdown position marking lights. There are FATO lights and green FATO lights on this side. The difference being that in the manual, we recommend that where this FATO doesn't have load bearing, the lights should be white, and where it does have load bearing, the lights should be green. And that's a philosophy that we follow throughout the lighting system. Here we have the lights white this time because this is an aiming point and not a landing point. So it's a FATO with aiming point lighting. And here we have 3 examples of teal-off lighting, one with comprehensive lighting of the identification, the touchdown positioning, and the teal-off lighting. This one with lighting elements. And this one is a full hospital with the heliport identification marking, the cross, the touchdown positioning marking, and the teal-off markings. And briefly, chapter 6 is the heliport emergency response chapter. And this chapter is a comprehensive chapter. We haven't got time to cover it now, but it consists of 2 parts: the heliport emergency planning, which is a general part and the contents of plan, and the rescue and firefighting service, which talks about the required level of RFS, the staffing levels, level and method of protection, response time objective of meeting them, rescue arrangement, comms alerting system, RFS personnel, and means of escape. It has 2 appendices. One is an example of a task resource analysis, another one of a certification status of the aircraft, which gives you a clue in respect to the chapter of what sort of alleviations you can get if you reach a certain certification standard. And some examples of firefighting: this is a hydrant throwing well clear of the deck. This is a deck integrated firefighting system. And this one's another one showing a very sophisticated one with the heliport markings as well. And that is a quick gallop through part 2 of the heliport manual. At some stage, it'd be interesting to know how many of those in the audience have actually seen a copy or read the copy of the heliport manual, but I can tell you it's a very comprehensive document. It has more than 150 pages for part 1 and the same for part 2. There are close to 200 diagrams, 30 tables in part 2, and a similar number in part 1. And so I recommend to you that if you're just interested in heliport design or in operations generally, even if you're an operator, it is quite an interesting read, especially the conceptual appendices in chapter 3 and chapter 4, which deal with the whole subject of why we do certain things in the annex and in the manual. And once again, thank you very much indeed.
Jim, thank you for your presentation. Very interesting, going through the chapter. I know that we'll have many questions at the end on this session. Actually, I have some on the Q&A section, so please, I will kindly ask you and Arturo to check that out and try to reply on the Q&A box, but we can also address them at the end in order for you to reply in the Q&A opportunity, and also have some questions from the email, so I will address them later Again, thanks, Jim, for your presentation. Now we'll have a quick break. Let's return at 10:40 Lima time for the final 3 presentations. Okay. Thank you very much. Thank you, Jim. See you at 10:40 Lima time. Okay, thank you. We are back. I will set these things up. Let me switch to Spanish now.
Sí. Muchas gracias, Fabio. Vamos a compartir. Muy bien, pues creo que ahora
Very
todo el
well then.
mundo sea capaz de...
I think that now,
Vamos a ver un segundo que cambio mi canal. No sé, Fabio, cómo cambiar el canal.
Fabio, I'm not
de
sure how to change
lengua.
the interpretation channel. Okay, I have switched to Spanish, so I won't have to hear both myself and the interpreter. I think I'm good now. So we are now going to talk about the experience we have had in Spain with the certification of our heliports. We are going to explain the airdrome classification scheme that we have in Spain to see which role airdromes play in this global classification of Spanish airdromes. And then we will look at which heliports have been certified, which is the Spanish legislation on certification of heliports. We are going to briefly look at why accidents and incidents are produced at heliports and which are the benefits of the heliport certification process, of which Spanish heliports have benefited from, and what is the future of heliport certification. Very well. In Spain, just to explain it in simple terms, we have large heliports, medium-sized airports and heliports, and small heliports. So we have the large airports, the large infrastructures, which are certified under EASA's regulation, under regulation 139. And we have a total of 36 large certified airports in Spain and its islands. And these airports, as I said, are the large airports open for public use, for commercial air transport, and they are under EASA's regulation, as I said, because they have instrumental approaches and departures, and they are open to public use, and they also have commercial air transport. So there we do not have our certified heliports. There are 36 certified airports, but there are no certified heliports. On the side of small infrastructures, we call them also of restricted use. They are regulated under the Royal Decree 1070. These are small infrastructures where currently no commercial air transport is allowed, and they provide private general aviation, aerial works, maintenance, training, HEMS, wildfire fighting, emergency, medical issues, etc. Then we have a number of airdromes, medium-sized airdromes and heliports, which are open to public use and where commercial air transport is provided, but since they are smaller than the large ones, they are exempt from meeting the European regulation, either because they do not have instrument approaches or departures, or because they have under 10,000 passengers per year. So we have 9 certified airdromes under the Spanish national standard, which is a national Royal Decree 862. Instead of certified, we call them verified to distinguish them from the large certified airports. So we have 9 verified airdromes and 3 verified heliports. That means that the heliports that we need to certify with respect to the future regulation of ICAO in terms of certification are already certified in Spain for a number of years, and we only have 3 of those. So the scope is quite reduced. Nevertheless, this doesn't mean that in the future we might not experience a growth of heliports for commercial air transport, and we might have even more. Which heliports do we have in Spain that are certified or verified, as we call them? So here you can see the Iberic Peninsula, and we have one which provides service to the Formula One circuit in Barcelona. And we have 2 in Africa. Sorry, we have 2 in the south, one close to Algeciras, and the other one in Ceuta. The mission of this heliport is to connect the Spanish city in Ceuta, which is in the north of Africa, with the port of Algeciras and the airport of Malaga. So in the south of Spain, we have like a triangle. The city of Ceuta is communicated with Algeciras and Malaga through a helicopter. So these are the only 3 heliports open to commercial traffic and certified that we have in Spain. The other heliports, around 200 or over 200 heliports in Spain, do not have commercial air transport open to public use, so they do not need to be certified. Well, here you can see, for instance, the heliport of Ceuta, which is in the north of Africa. It has an operator called AENA, which is our main airdrome operator. It operates, there's one single company operating them, Helity, which is operating the AW139. It is a public use heliport for commercial operations, and it also has HEMS operations and police operations. It receives visual operations at night and day, and it has a FADO of 245 per 30 meters and TLF for 4 stands. This is critical for the city of Ceuta because it communicates the city of Ceuta with the Iberian Peninsula, and it allows to carry out any medical evacuation. As I said, it is located in the city of Ceuta. This heliport communicates with both the airport of Algeciras, which is in the port of the city of Algeciras, and also the airport of Malaga in Spain. Then, in addition to the Ceuta heliport, we have the Algeciras heliport, which is a very small heliport, as I said, elevated with a FATO of 32 per 24 meters, public use, commercial operations, also HEMS police operations, BFR at night and day, and it is operated by AENA, and it's of public use. Then we have a heliport, which provides commercial operations of private use, which is the one of the Barcelona race circuit. These are the only 3 certified heliports we have. Here you have an example of those dedicated to public passenger transport, which are those from Ceuta, which is, you can see that the heliport is close to the bay, and the one of Algeciras, you can see it is an elevated heliport on top of a building. How has the traffic evolved in these heliports? You can see the evolution of the Ceuta heliport. It either goes to Algeciras, to this heliport, or it goes to the airport of Malaga, and here you can see the evolution. After the crisis of 2008, there was a peak and then a significant dip. The company providing services bankrupt. We had a number of years without service, and then the Elite company was introduced, and we have been able to reach peaks of over 70,000 passengers in the city of Ceuta. This is the traffic volume that we currently have at this heliport. Very well then. Which is the Spanish regulation for the certification, or as we call in Spain, verification of this heliport and airdromes? Well, it is a royal decree of the year 2009. In 2009, in Spain, they published in the official bulletin of the state this royal decree for the full certification of airdromes and heliports. And they anticipated that in addition to certifying airdromes, they were also going to certify heliports. This was a decision made under the Spanish Civil Aviation Authority and the Civil Aviation Safety Authority that decided to certify the heliports as well. How were heliports certified? They were certified with a technical standard, which is the Annex 14, Volume 2, which was applied to the Spanish legal status, and through a heliport manual, which described the structure of the heliport, the management of the heliport, the procedures of the heliport, and obviously the SMS system required for the helicopter according to ICAO's SMM principles. So they were certified under this standard, which is now under review. We are working in a project to review the Spanish legislation on airdromes, and it is under review, as I said. We will incorporate the new developments of ICAO with respect to the certification of Annex 14 for the certification of our heliports, and we are now reviewing this Royal Decree 862 from the year 2009. Well, now we are, oh, sorry. Why do we certify, or why in ICAO is going to ask us to certify heliports? What benefit can we obtain from the certification of heliports? Do we actually have to certify heliports? Is there a need for this? Well, let us take a look at this. One of the actions we took was to try to justify why can we benefit from the certification of heliports. Accidents are produced at the heliports? Well, based on the existing literature and existing studies on accidents and incidents and its main causes, well, we found some documents on accidents of helicopters in Europe and another document of accidents of helicopters in the US, and we were able to draw some key conclusions. This is a chart taken from the European Helicopter Safety Group, a report from 2015, where they looked into helicopter accidents in Europe between the years 2000 and 2010. So they found that the infrastructure, the heliports as such, were present as an important causal factor in almost 10% of the accidents. In the United States, they found something similar, and they made a hierarchy of which are the problems at the heliports that lead to accidents. They saw that from all the accidents in the United States in the period between 1965 and 2013, the obstacles were present in a large amount of accidents, above 50%, almost 60%. Design failures at the heliport, they were present in over half of the accidents, over 50%. Improper size of the FATO or TLOF, it was present in 25% of the accidents. Wind considerations, wind issues, that is a improper consideration of the wind present in the facility at the heliport, it is present in almost 20%. Improper training, aircraft mechanical malfunction, obstructed approach, departure paths, site location, communication errors, mid-air collisions, lightning, and other causes are present in the heliport accident. So here we can see that from an adequate certification process, we'll be able to avoid obstructions, design failures, we will avoid or prevent the helicopters from operating in helicopters with improper sizes. We'll be able to provide adequate weather information. We'll be able to provide proper training to the people working at the heliports. We'll be able to work on the different causal factors that affect the number of incidents and accidents at heliports. So which are the benefits of the certification of heliports? Well, we are going to be able to fulfill with the SARPs, which are the standards and recommended practices of ICAO. Will be able to publish adequate heliport data. The physical characteristics will be adequately designed to accommodate for the helicopters expected to operate in the heliports. We'll be able to address obstacle limitation. We'll be able to have adequate visual aids and adequate electrical systems. We are going to provide the helicopter with a number of critical services such as emergency response, the rescue and firefighting services, and the maintenance of the heliport itself. And we'll be able to have a manual where we'll ensure that there's an adequate publication of AIPs, an adequate obstacle protection, an adequate wildlife protection or bird protection, adequate procedures for safety at the apron and FATO, adherence to procedures and industry best practices. Additionally, we be able to have an adequate coordination between the operator of the aircraft and the operator of the heliports, because many times we have realized that in the case of heliports not operated by the helicopter operator, there was no adequate coordination between the heliport operator and the helicopter operator. Also, the certification procedure will allow us to have a process of continuous oversight by the authority that will lead to a continuous improvement in terms of the safety of the heliport. The continuous inspection of the Civil Aviation Authority has been able to address many concerns on safety that could be present at those heliports that no longer exist, and these heliports are much safer than before. Additionally, in addition to providing the heliport with a certification system through which we'll be able to ensure compliance with the safety management system, so the heliport will have a manual and it will have a continuous oversight system. As I said, we will provide it with a safety management system. Why can a heliport benefit from a safety management system or an SMS? Very simple, because we'll be able to provide the heliport with a system as simple as possible, so it can systematically evaluate its risk with the involvement of the different stakeholders, including the helicopter and heliport operators, the local authorities, the port authorities in the case of our heliports in Ceuta and Algeciras, which are located in the ports, maritime search and rescue in case there are accidents on the sea, also coordinating with other heliport operators such as the hand service, the police, and other air navigation service providers. For instance, these service providers that I'm mentioning here, the SMS will also allow us to start gathering data on heliport safety because we have safety reporting systems established. We have started to collect safety data at the heliports, and there's a difficulty regarding the large safety management system in the large airports. As you know, ICAO tells us that the SMS is a data-driven process. It is a process where we need to measure to see how we are doing in terms of safety. At the heliport, it is difficult to develop safety indicators that will allow us to see how we are doing in terms of safety, because usually number of operations is not that high, and it is more challenging to establish indicators that have and statistical significance, that are statistically significant. However, over time, the Spanish heliports have been able to obtain some indicators that allow us to look at the status of operations. But the most important part of this SMS is not so much the possibility of providing safety performance indicators, as well as the possibility of systematically managing the risks and gathering the best safety information possible. How can we improve the certification of heliports in Spain? Where are we heading in the future with the certification of heliports? And what can help us with the certification of ICAO? Well, the heliports tend to be sites. They are not like the large airport. These are rather small sites. Facilities in Spain, for instance, in Ceuta and Algeciras, there's one single commercial operator, which is ECMLK. These are organizations, small organizations. They are not complex organizations. So how can a small and non-complex organization benefit from this? It can benefit from a heliport manual and an SMS, which are very simple, that will not impose an excessive work burden or red tape, and will help them have their procedures better organized in a very simple manner, and providing information about difficult operations. So one of the issues that needs to be addressed in Spain, and we will address it with our legislative change, is the simplification and improvement of heliport manuals so they can become straightforward tools. The evolution of the SMS. The SMS are present. All the pieces of an SMS are operational at the Spanish heliports, and what we need to do in the future is to move from a state where they are operative to a state in which they are as efficient as possible with the minimum level of effort possible. We also need to foster a safety culture that we have already started. It's quite incipient, where there are people who are fully convinced of the benefits of a safety culture, but still we have a group of workers and users of large infrastructures that need to be educated on safety culture so we can have a better future in terms of safety. Finally, and even though we have already started on this pathway, it is very important to have an appropriate coordination between heliport operators and helicopter operations to achieve better safety in the operation. So this is the future we are heading towards in terms of the certification of heliports in Spain. Having said this, we have finished with this presentation. If you have any questions or comments about this, perhaps we can address them during the Q&A session. And my colleague Fabio has already asked me about some issues related to certification that have been responded in the Q&A box. If not, we can further discuss them at the end of the presentations. And thank you very much.
Thank you, Arturo, for your presentation. Very interesting experience Spain has had. In fact, there was a question for you, but we'll leave it for the end. Let me now move on to English to introduce the next panelist.
Thank you again, Arturo. Now I'm happy to introduce Maria Paula Borges de Macedo. I don't know if I spelled it correctly, Maria. So Maria is from Brazil, and she's graduated in business administration with a master's degree in business management and logistics. She works as a regulation specialist at Annex, Brazil since 2008 in the area of aerodrome safety. Since 2019, coordinates the team responsible for the registration of heliports and is a current member of the ICAO Heliport Design Working Group at the ICAO headquarters. So Maria, are you ready with your presentation?
Yes, I'm ready. Can you hear me?
Really low, but yes. It's better now.
All right, I'm going to share my screen. Just a second. Can you see it?
Yes.
Yes. Okay. So Fabio, thank you for the introduction. You spelled my name correctly. It's okay. So I work at ANAC. So I'm going to share with you today some of our experience with the regulation for heliports, design and operations. Just a quick overview on ANAC. ANAC is the Brazilian Civil Aviation Authority. We are responsible. Yes?
Sorry to interrupt you, but at least myself, I'm only looking at your PowerPoint with all the menus, etc., not a full screen mode. I don't know if you put it that way.
Well, I put the presentation mode. It's not. You can't see the presentation, or I don't understand. I'm sorry.
Sorry, I got disconnected. I see the presentation, but I saw it in with all the menus. It's not in presentation mode. Is that okay? Do you want to do it that way?
Yeah.
I'm not sure how to do. I put the presentation mode on the PowerPoint, but maybe I have to do something on the Zoom. I'm not sure.
Sorry, Maria, I can't hear you. Maybe it's me, but I hear you really low.
Can you hear me? Everyone, I'm going to put the phone, the headset. Maybe it helps. Just a moment.
Okay.
Is it better now?
Yes, it's better.
Yes? Okay.
I was
Well,
telling you that I see the presentation, but with all the PowerPoint and all the menus, it's not on presentation mode.
Well, I don't know, because I click here on presentation mode. I'm not sure what I have to do to change this. I guess I have to continue that way because I already clicked here on presentation mode.
Okay, sometimes
not
it
sure.
happens. Okay.
Okay, well, I think I have to continue like that.
Yes,
Okay.
Please continue.
Okay, I'm sorry about that. So ANAC is the Brazilian Civil Aviation Authority. We are responsible for the regulation and inspection of civil aerodromes in Brazil. As you know, Brazil has a large territorial extension, so we also have a large number of aerodromes in our country. And this is quite a challenge for the regulatory agency because our human and financial resources are scarce, and it is difficult for us to cover this large territory we have with so many aerodromes. It is also important to say that the airspace regulation is the responsibility of the aeronautics in Brazil, and the offshore helipads, the helidecks, are regulated by the Navy. So in the scope of ANAC regulation, we only consider the onshore aerodromes. So when we talk about the onshore aerodromes, we have in Brazil now around 500 public use aerodromes. Only one of them is a heliport. We only have now registered in Brazil one heliport. As for the helipads designated for private use, we have over 1,300. And private use aerodromes for fixed wing only, we have around 2,200 aerodromes. So if you add up all these categories, you will reach an amount of around 4,000 aerodromes in Brazil. So back to the helipads, as I mentioned, we have around 1,000 helipads in Brazil. Out of these 1,000, more than 400 are elevated. These helipads are concentrated mostly in the southeast part of the country. As you can see here on the map, the region of Rio and São Paulo is where you have the largest concentration of helipads, mainly São Paulo, more than Rio. I have put here two images, Google Earth images of the downtown area of São Paulo in Brazil, just for you to get an idea of the quantity, the amount of elevated helipads and how close the fatals are. So in this first image, you can see that the fatals are there. Yes?
Maria, sorry to interrupt you again, but it seems that the presentation is not moving. I'm watching just the overview slide. Maybe if you just stop sharing and try to share again, then it will, connect again, but something is wrong with the
Oh God, okay, I will do that. Just a moment, I'm sorry.
Thank you, sorry about that.
Can you tell me which slide is on screen now?
On the screen, I see the PowerPoint with all the menus on top, and I see a slide number 2, overview.
Oh God.
Yeah, something is happening here. Now
Yeah,
you're
I'm not
moving.
sure.
Yeah, now you're moving, but it's still on the PowerPoint with all the menus, etc.
Yeah, I don't know how to do that because I clicked already on the presentation mode. For me, it seems okay, but Did you see slides 1, 2, 3, 4, 5 when I passed them or no?
Yes, you can go
Yes.
maybe on a
7?
presentação, the slides on the menu on top. There, the right, that one. And
Okay.
that do slide actual, that one. You already press it? Doesn't happen?
Yes, I pressed already.
So
Does
and
it show
the
or-
next, no, it's not showing. The next button, a presentação, the slides personalizada, maybe that one.
Yes.
Huh? Something is, I don't know why it's no, close that one, please. And let's do something. If you select the slides from the left, then everybody can see the slides there.
Yes, I am selecting slide number 7. Can you see it?
Yes.
Yes. Okay, I think
Mhm.
I'll have to move on like this. Yeah, I'm sorry about that. So on slide 7, as I was saying, we have some Google Earth images of the downtown area of São Paulo. You can see that, right? 2 pictures here. They show, it's just to show the concentration of elevated helipads we have in the urban centers of Brazil. FATOs are very near to each other. On the first picture, FATOs are distant only 34 meters from each other. In the other picture, we have a 69 meters distance between one to another. So this is just to show how is the concentration of helipads in Brazil. So as for the regulation background, we have ANAC was created in the year of 2005. By that time, the regulation in force was this Portaria number 18, a regulation from 1974, a very outdated regulation. And ANAC was created on 2005, and we updated the regulation. We wanted to align our regulation for heliports with the Annex 14. And on 2018, we published RBAC number 155 for the design and operation of heliports. So how did we come up with the applicability for RBAC 155? When it comes to, because as we all know, Annex 14 is mandatory, the volume 2 is mandatory for heliports that operate internationally. But in Brazil, this is not, it's not adequate to our reality, because the only helipads that would maybe operate internationally are the ones located in the border of the country. And we already saw that the concentration of helipads is mostly in the southeast of the country. It's not on the border. We have over 1,000 helipads, and nearly 500 of them are elevated. It's a high quantity of elevated helipads. There's a high concentration of elevated helipads with very near FATOs, as we could see on the previous slide. And we also needed to address a regulation that would enable us to do an effective monitoring. So when it comes to risk assessment, ANAC decided to prioritize the operations in the urban centers, as we understand the risk is higher. So if you consider São Paulo, for example, which is the biggest urban center in Brazil, there's around 200 helipads in São Paulo, and 175 of them are elevated. So almost all of them are elevated and are located in the the applicability of RBAC 155 was defined as follows on this slide. The regulation is mandatory for public use heliport, is mandatory for public use aerodrome components designated exclusively for the operation of helicopters. So if you have an airport, a public aerodrome with FATO and parking positions and taxiways designated for helicopters only, those components will have to meet the requirements of RBAC 155. It is also mandatory for elevated helipads, and it is recommended for helipads on ground level. When the regulation was approved, it was said that ANAC will have to evaluate the regulatory impact within 3 years. This evaluation is under course. We have started this on last year. It's not complete, but is under course. And I have mentioned here some the transitional and final provisions of the RBAC 155. The first transitional provision says facilities registered or in the process of being registered before the 21st of November 2018 must comply with the provisions of RBAC 155 when they are replaced or improved after this date to accommodate more demanding operations. So if you have a helipad that was registered, when I say registered, I think I mean the same as Artur when he said verified, certified, we call a registration process. So if you have a helipad that was registered before RBAC 155, it will not have to meet the requirements of the new regulation. It will only have to meet the requirements if it makes a change to accommodate a more demanding operation. Otherwise, it won't have to meet the requirement. So if you have a helipad registered before 2018 that makes a change to accommodate a larger aircraft, you have to increase the fatal dimensions or maybe change the VFR procedure to IFR, then yes, and then the operator will have to meet the requirements of RBAC 155 for the whole infrastructure. Otherwise, it doesn't have to. The other transitional provision says that in order to comply with subparts D and E of this regulation, helipad operators must comply with the rules on prior authorization for the construction of aerodromes and their registration with ANAC. So subparts D and E, they relate to physical characteristics and visual aids. So if an operator needs to make a change on the physical characteristics or visual aids, it will have to ask ANAC for prior authorization for the construction when it comes to physical characteristics, and then afterwards the registration to update the information, okay, on these characteristics, physical or visual aids. And there is also a final provision on RBAC 155 that says that ANAC may establish specific requirements for any aerodrome as long as it is previously justified and depending on the complexity of the operation, the movement of aircraft, or the risk to operational safety. So this final provision is just to say that ANAC, if we, as a regulator, identify that there is a higher risk on some specific operation, on some specific helipad, we can ask the operator to meet some additional requirements. So just to talk about the registration process, because I mentioned before on the previous slide about the registration process, which is the verification we do here in ANAC before register the helipads or heliports. So the first step is that the operator requests ANAC authorization for construction. We then issue this authorization. The operator then builds the heliport or helipad and requests ANAC for registration. When he asks the registration, we examine some documents, and if it is a heliport, a public use heliport, we will do an on-site inspection based on RBAC 155 requirements. If it is an elevated helipad, we will do a remote inspection, also based on the requirements of the regulation. And if it is an on-ground helipad, for which the regulation is not mandatory, it's only recommended, we will do a basic evaluation based on some information the operator provides in the file he needs to fill in. So after this verification, we register the heliport or helipad, then we open it to air traffic, and we request aeronautics to update publications. Aeronautics then update the publications, and the process is concluded. So here is a picture of the heliport Farol de São Tomé, located in Rio. This is the heliport we have, the only one, as I mentioned before. For this heliport, we did an on-site inspection. It was the only on-site inspection we did so far using the RBAC 155. This is a heliport that serves mainly the offshore operations. For elevated helipad, as I mentioned, we do a remote inspection. It's not an on-site inspection. We do a remote inspection. It is based on a checklist. Here's I hope you can see it well because it's not on presentation mode, but this is a checklist we send to the operator. We list here all the requirements from RBAC 155, and we list on the third column here the form of proof of compliance. So we say here to the operator which evidence he needs to send us in order to prove that he's compliant with the requirement. So it can be a blueprint of the heliport, it can be pictures, videos, for some requirements, if he presents a declaration signed by the engineer that is responsible for the construction, it's acceptable. So we have the form of proof of compliance for each requirement listed on that document, and the operator needs to fill in this document and send the evidence for our analysis. When it comes to the on-ground helipads, the requirements of the regulation, they are not mandatory. As I said, they are just a recommendation. So we do a basic evaluation just on the dimensions of fatal and sea loft that he declares, just to see if there's nothing severely out of standard. So we just make sure that the dimensions declared are okay with the regulation. And if he's willing to operate at night, we check if he has the fatal lights and the illuminated windsock. So that's it. I hope you guys could see it well, because I don't know what happened here. I could not do the presentation mode, but that's my presentation. Thank you very much.
Thank you very much, Maria, for your presentation. I do apologize about the technical issue, but also we'll have that presentation on the website for anybody who wants to see any detail on the presentation. So going to the last one, I would like to ask Arturo again to join us now to do a brief introduction to Vertiports on behalf of EASA. Arturo, the floor is yours.
Muchas gracias. Cambio al canal español.
Thank you very much. Let me move into the Spanish channel. Well, initially we had invited Mr. Sekulic, who is the coordinator of Vertiports of EASA, to present the development of EASA on Vertiports, but unfortunately, he had some other engagements that have not allowed him to be with us, but he has asked me to make the presentation on his behalf, because I've been part of the team that's developed the regulation, or the prototype regulation of what's been published by EASA already. So let me briefly describe this regulation for about half an hour, all right? All right, let me share my screen. Can you see it now? Yes. Let's talk about what EASA is doing in terms of vertiports. what do we need vertiports for and why? What is all this about? As you know, the industry is developing vertical takeoff areas and aircraft like this one that are electric and able to take off and land in a vertical fashion, though the battery lasts very little. Their ability to fly is quite good, and they'll be able to do some things that some helicopters won't be able to do. They'll be quite versatile, and what are being built are smaller than helicopters, so probably they will be operating in cities, and they will probably need some dedicated platforms that will be called vertiports, that will be very similar to heliport, not exactly the same, and that is why they will need an independent regulation. So as I said in my previous presentation, some of these aircraft are like this one you see are in the certification process. So hopefully by 2024, 2025, they will have been certified. Hopefully we reach that deadline. Maybe we'll be a bit delayed, but that's the plan of the manufacturers. So they will start operating after getting the certification. So we'll be starting quite soon, probably 2025. Well, so we need regulations for vertiports so that the operation of this type of aircraft can be safe. Now, the EASA Management Advisory Board concluded that the VT design requirements are of common interest of European Union member states, and that EASA was to develop some guidance material for vertiport design. And this is a first step. It's a prototype of regulations that could be used by the states for the time being, so that they can develop their own material for vertiports. So as I said, EASA has issued a prototype of technical specs, but that will be developed in the future. But this can be used by the states. It's just some guidance material. It's not mandatory. It's just a prototype of specifications presented as guidance material so that the states can use to develop their own regulatory framework. Now, of course, in the future, this guidance prototype of technical specifications, which are technical specifications, will be evolving towards a full EASA regulation that will include technical standards and regulations for vertiports. And EASA is expected to complete that by 2025. So let's see. In view of all this, EASA created a vertiport task force with some 48 members, including VTOL aircraft manufacturers, EASA experts, civil aviation experts, and even airdromes. A very important mixed force to develop this prototype of technical specifications. What have we done? We've prepared these technical specifications starting from scratch. Is that the case, or where have we been based on? Well, helicopters, remember, are also aircraft. So what EASA has basically done is to take Annex 14 and use it as a guidance material to develop a prototype specifications document for this purpose, for vertiports. So to do this, since there were no detailed information about this issue, we've had the participation of VTOL manufacturers that have contributed to the development of these standards based on the data they had. So as I said, the first step was to develop the prototype technical specifications published just this first quarter of 2022. This is non-regulatory material. It's just a prototype. What for? Is for aircraft that will be operating under VFR conditions that are certified in enhanced category. What does that mean? Well, it means that what Europe is expecting in the near future is to develop under European VTOL operations with these aircraft. So in principle, they will be using visual conditions and also manned. So they will be certified in a category called by EASA as enhanced category, which is equal to performance 1 of helicopters. The vertical takeoff aircraft certified in enhanced category could continue flying under a critical failure of the system, just like helicopters, the performance class. Well, so bearing this in mind, EASA has developed some technical standards similar to Heliports for visual manned and certified aircraft equal to performance 1 to 5. And the contents of these specifications are similar to Annex 14, Volume 2, though it includes regulations for alternate vertiports and en route vertiports, but it does not have any regulations on other designs, as we will see later on.
What is EASA going to do in the future for 2023, 2024? It will take this prototype of technical specifications and include them in a prototype guide to actual specifications for heliports that will have the full package of regulations of the European Union. They will have the equivalent of Annex 14 for vertiports and a whole certification regulation of these vertiports that, since they're going to be vertiports for commercial passenger use, open to public use, and in the future they will be for instrumental operations. They will require certification according to EASA. So now we are going to briefly describe this standard on the vertiports. It has been, whoever wishes to download it can download it from the website of EASA. You just need to Google for prototype technical specifications. And on the presentation that I have sent that you will find on the website of ICAO, there's a link to download this document if you want to review it further. The prototype technical specifications for the design of VFR Heliports. This has been a unique opportunity to develop a standard, an adequate standard for a vertiports. It has an innovative approach. Which means that the standard is adjusted to accommodate for the location of heliports in urban areas. And it has been the first set of specifications that has been published for vertiports globally. Then we have had others, such as those from the FAA. Now, what is the content of this prototype specifications, technical specifications? We have a chapter A, where you will find general aspects. They talk specifically about applicability. It applies to vertiports for aircraft in the category of enhanced in visual and manned flights. And you will also find a few definitions as a chapter B, where we talk about vertiport data that we need to communicate to the IP. Chapter C on physical characteristics, very similar to the helicopters, where they describe FADO, tail-off, stance. Chapter D on obstacle environment, where they take into account some surfaces similar to heliports, where they provide a new form of limiting obstacles through a simplified volume of space that we will look at later on. They have designed a specific visual aids for these facilities, especially markings and markers. They have regulated on the en route alternate vertiports, and we haven't been able to regulate on the RFFS services because EASA didn't have any data on fires from lithium-ion batteries, which are critical for this type of aircraft. And for this, EASA needs the assistance of the industry so they can regulate this in the future. So moving into the applicability, non-regulatory material for the design of a vertiport for, as we have said, manned VTOL capable aircraft certified in the enhanced category and in the visual flight category. Within the definitions, they have included the definition of vertiport, which is equivalent to that of heliport, but for vertical takeoff aircraft, and they have included D for a VTOL aircraft. D is the maximum dimension of the vertiport for VTOL aircraft. It has been defined as the smallest circle enclosing the VTOL aircraft projection on a horizontal plane. As to the vertiport data on chapter B, what we have done is to transfer what ICAO requires in volume 2 for helicopters, and we have shifted that some set of data to be provided for the vertiports, including the coordination with the air navigation services and the AIS, the Aeronautical Information Service. As to the physical characteristics, the chapter on physical characteristics, the principle that we have followed for its development is the same principle of Annex 14. That is that the vertiports will be designed so as not to have no more than one VTOL capable aircraft in the FADO at the same time. We have followed the principle of building blocks that Annex 14 provides for, and we have included our requirement. There was a concern, a significant concern on the side of the manufacturers, so that reduced spaces where these operations are going to take place could allow for almost simultaneous operations, which are very close in space between these aircraft. So we have included in the chapter of physical characteristics, the idea that whenever they want to set FATOs, which are close by, we need to see to what extent they can have simultaneous operations, or perhaps the FATOs are too close in distance and they cannot carry out simultaneous operations. All of this is based on D value. And there's another news on the side of physical characteristics, and that is that the helicopters have a design of stands with an area of protection which is quite large, and this area of protection is due to the protection required by the rotors. But the vertical takeoff aircraft will have the rotors scattered in several sites, and many times they will be enclosed, encapsulated, and they do not present the same level of hazard than a helicopter rotor. So stands have been designed with the shape of an envelope, and they require less space in the apron for parking this aircraft. So this is one piece of news in chapter C on physical characteristics. As to the obstacle environment on chapter D, with respect to this chapter, we have done a couple of things. On the one hand side, we have maintained the obstacle limitation services found in Annex 14 and the Heliport manual. We have thought that there could be VTOL aircraft operating similarly to that of helicopters in operation, and we have maintained the same set of surfaces, conventional surfaces, than for helicopters. But additionally, we wanted to provide the EASA standard with a more simple way of limiting obstacles. And since EASA will require, through the certification of aircraft, that aircraft should be capable of operating within a certain volume of space, even with a critical failure of their propulsion systems, then a simple surface system has been designed, known as airspace volume, which has this shape that you see here on the left for landing and takeoff, or it has a circle shape if we wish to have takeoff and landing in any direction of the space. So this obstacle-free volume that you see there is a simplification of obstacle limitation surface based on the certification regulation. The aircraft will be capable of landing and takeoff with that obstacle-free volume, and this will allow us to establish an OLS much simple than that of helicopters, and that is a volume that has been tested in different cities, and it allows to land and take off with a broad vertical component, so they can sort out the difficult obstacles that we have in the urban setting. So we can also locate vertiports in urban areas that have a high number of obstacles. In terms of visual aids, well, the markers and lights are completely similar to those of heliports. We have redesigned the symbol of identification of heliport, and it has been changed to a vertiport identification marker, which is a V in white, since we hope to have FADO which are closer between each other. We have designed it this way, but the markers are very similar to those of helicopters. The only difference is that we have changed the scale of the markers because the currently designed aircraft are smaller than the current helicopters, so they will be provided with smaller FADOs, and we have proportionally decreased the size of the markers to adapt them to these FADOs, which are going to be smaller because the aircraft have smaller sizes, but they are essentially the same, the markers and the lights. Finally, EASA wanted to also regulate on route alternate vertiports. What happens if I take off and I go from a vertiport of origin to a vertiport of destination, and whichever reason I need to go back to the origin and I cannot go to the destination, I need to look for an alternate destination, or I have a problem during the flight and I need to land. EASA has regulated on the minimum characteristics that all these alternate vertiports should have en route, on destination or origin. So these are suitable surfaces. So if one of these aircraft transporting passengers can have a continued safe flight and landing during a flight. So this has been added in Chapter F. And as I said here, we still need to talk about the RFFS, the Rescue and Firefighting Services. And as I said, EASA is expecting the collaboration from the industry to have a better idea on how to regulate fires caused by batteries, which are going to be very different from fires caused by fuel aircraft, and they are going to have different RFFs. So that chapter is under development in the technical European standard. So once again, conclusions, and with this I will be done with my presentation. EASA has provided a prototype technical specification that is going to be used as a guidance for the design of future vertiports to the designers, the industry, the planners, the urban planners, and to the operators and whoever needs it. This standard needs to be tested once the aircraft are certified and we have data on aircraft. It needs to be further modified and enhanced. This is a first step for the second step that EASA will take, which is the final development of the standard and the full standard for the certification of this type of facilities, the vertiports. Well, we know that several vertiports will be installed in urban environments, and this will be a challenge to local spatial planning authorities and for the land use design and the urban planning in general. As we have said, in the next rulemaking, we will cover the full vertiport certification in EASA. And in the meantime, the civil aviation authorities should plan for resources, competencies, and they should be thinking that in the near future, we will have to certify this type of facilities, vertiport, in a future as close as 2025. And EASA is committed to further coordination with ICAO to reach a global harmonization of this type of requirement, even though ICAO will regulate and will establish the standardization and global harmonization of the vertiport requirements. If EASA and FAA are also going to develop a vertiport regulation, this should be done in a coordinated fashion along with ICAO, so the different developments can reach a common point, so we can have a coordinated and standard regulation for these infrastructures globally? Well, essentially, I don't know if I went beyond the time allotted for my presentation, but this is what I wanted to present about Vertiport. So once again, thank you very much, everybody. And I believe that now we are going to move on to the Q&A session. So I would like to give the floor back to Fabio. Arturo, thank you very much for your presentation. Yes, actually, you were 5 minutes earlier, so do not worry about the time. I wish to thank all our panelists, all the different speakers who have shared their experiences and the work they have been doing in the Heliport Design work group. So now we have the opportunity to ask direct questions to our panelists. The dynamic we wish to follow is that there is an option for raising your hand on the Zoom menu. If anyone wishes to ask a question right now, please feel free to use that option. First, briefly introduce yourself and please indicate the state you are representing, and then you can ask your question. Well, while that happens, I would like to read a question that we have on the Q&A session, which is in Spanish, and I will read it so the interpreters can help us with interpretation. Well, based on the experiences of other states, would it be feasible to incorporate in the next amendment of document 9261 a table with the types of helicopters, performance, or its corresponding slope design category, whether A, B, or C? I don't know if anyone wishes to answer that question. Any of our panelists?
Fabio, I can answer.
I don't know if you can hear me.
Yeah, do you want me to answer that? Okay. It was a question raised in Spanish, so I already had a look at it. And was the question in the next edition of 9261 that there should be an alignment between helicopters and the type surfaces? Is that the question?
Let me put it on the screen, Jim, so that you can look at it. I'm using Google Translate, so I'm sorry about that.
Yep, do you want me to continue?
They are going to translate the question for you.
I already translated it in Google. Was it based on the experience of other states it would be feasible to include in the next amendment to document 9261 a table with types of helicopter performance of their corresponding slope design category? Is that the question? Okay. There is no direct correlation between the performance classes and the slopes. There was in the original manual, and there was in the original ICAO table, but it doesn't work quite that way. These slopes are designed to, they're obstacle limitation slopes. And so you check your slopes to see what you can achieve. Now, if you've got a performance class 1 heliport, then obviously you have to account for engine failure. You have to have engine failure accountability. So you have to account for one engine in operative flight. If that's the case, it's unusual for any helicopter that's lost an engine to be able to meet the 12.5% gradient. They can all meet all modern aircraft can meet the 4.5% gradient. In fact, it's better than that, because in the first climb segment of a category A performance, the aircraft can actually, most aircraft can reach 10%. So they're actually a lot better than 4.5%. They're not as good as 12.5%. So there's no direct alignment. Performance class 1, sorry, a class 1 heliport should have a class A slope, Any of the others, if it's not a performance class 1 heliport, can have any of the slopes. And there's no direct correlation apart from the fact that if you want engine failure accountability, it is advisable to put in a 4.5% slope. So we've just taken that out. And so it would be strange for us to put it back in again. We don't want each slope to be associated with a particular performance class of helicopter.
All right, thanks. Thanks, Jim. I'm gonna switch to Spanish right now.
Thank you, Jim. We have another question by email from our colleague, Carlos Garcia from Uruguay. Carlos, if you are around, can you please ask your question directly? If not, I will try to summarize the question you were asking. Mr. Lyons, can you please turn off your microphone? Thank you. Among some of the questions, we had a question on elevated heliports, and Carlos was asking about the drainage management, the rainwater drainage, field drainage, in the case of spills, if there are any arrangements or provisions for that on the manual. I don't know if one of the panelists can answer that question.
Fabio, can you just, what are the basic elements you're asking? What are you asking for an elevated heliport?
Yes, Jim. He's asking about if there is a specific guidance on the manual about the design of the drainage for, you know, rainwater and drainage for fuel in case of accident, you know, for elevated helidecks.
Okay, all heliport surfaces have to have a gradient, and the gradient's required for drainage. But there is a maximum slope of gradient, and that's all contained in Annex 14, and it's also contained in the manual as well. We repeated in the manual. So yes, there is a requirement to have drainage, and in the manual, there's in one of the appendices, there's also a test that can be done to make sure you get the appropriate drain off. And not only that, but on offshore, there are some helideck constructions that have gridded phaetos where there's a drain through and then a drain off the helideck. So that's in the heliport, in the offshore portion. In the onshore portion, it is just there is a minimum slope requirement, or there is a requirement, objective requirement, for you to have drainage, and there is a maximum slope so that it doesn't appear with this, it doesn't interfere with the stability of the helicopter. So there is no diagram that says you should put drainage slots here. There is one diagram in, I think it's Appendix B of Chapter 5, which talks about, it's a UK system that talks about a test that can be done on one quadrant of the elevated helideck to make sure that the drainage is adequate.
Thank you, Jim. So I got another question. Again, if somebody from the audience would like to do any question, even in Spanish, please raise your hand and do it. In the meantime, the other question that I have, it's about, you know, helipads or inside certified international aerodromes. Based on the experience from the States, maybe it's more for Maria and Arturo. How do the state deal with these facilities? If they are incorporated in the aerodrome certification process, and which process will they carry on for these facilities? If they use a specific list from the Heliports regulation, or how is this done?
Well, yes, let's see. EASA uses the criterion that the facilities, the parts of the certified airports that have areas of exclusive use for heliport, airports that have heliports inside the certification of that heliport is done as part of the airport. It is like an airport that has 2 runways. You do not certify runway A and runway B separately, but you separate the airport with the 2 runways. And if in addition that airport has a FADO, then they certify the airport with 2 runways and a FADO. That is EASA's criterion. And it is also the criterion that has been included in the text of the guide that will be provided in the Heliport manual on certification of heliports. That is, the parts of the airports to be certified that are for exclusive use of heliports are certified as part of the airport. So I don't know if this answers your question. Thank you very much, Arturo. Yes, I think it does. Very well. I would also like to tell you that on the Q&A box, there have been a number of questions that have been answered in English. Interesting questions about the certification of heliports that Arturo has already discussed, and also other questions on offshore heli decks. Those questions, even though they are in English, do not worry, but we will translate them. Both the English and the answer, both the question and the answer will be translated into Spanish, and we will publish them in the website of the event. I don't know if there are any other questions from the audience.
Fabio, while they're thinking, can I just, one of the questions that I answered earlier on was about why is there a flat surface? Why is there a clear way required? Can I show a couple of slides, 3 or 4 slides, indicating why that's the case? If
yes,
I can
please.
just grab the screen. I'll share the screen. The HDWG, in fact, my subgroup in the HDWG that deals with airspace have a mathematical model which we use to test hypotheses on surfaces and slopes and so on. And I've used that to provide a couple of slides to answer a question, actually not on here, but on LinkedIn, and a similar question was asked. Here we have a normal, a quite normal heliport. We have a takeoff surface, which is 4.5% gradient. We have an approach surface, which is a 12.5% gradient. And we have a requirement that for performance class 1, that the aircraft has to be at 35 feet before it reaches the takeoff distance required, which is this spot here. So an aircraft has to already be at that height when it takes off. So taking off from here isn't really an option. It has to be a vertical procedure. So here we have a vertical procedure. It's a 169. It's to scale. And we have the ascent, descent. We have the 1 engine in operative. We have the takeoff distance required, and we have the min dip. Now, this is fine, except this area here. I apologize for this box that says plot area. I didn't know that was on there. But this min dip is not provided by the manufacturers. They do provide the distance of the takeoff distance required, and they do also provide the drop down height. But as you can see, as the TDP increases, you go further back and you go up. As the distance changes, you go up an incline. So to work out what you do here, you have to use quite complex mathematics. And that's not for a pilot to do. too complicated. It's not because it's a pilot, it's too complicated unless you're sitting somewhere working it out. So what we have, we put a clearway in, and in that clearway, we provide a level surface here and the 35 feet, which allows the pilot to establish the TDP and establish that he doesn't penetrate the 35 feet before the OLS, and then clears the OLS further up. Now, if I just go back and show you, this is where the services are on the right-hand side. This is where the OLS is, and this is the 35 feet. Now, if I put the aircraft path in, this doesn't change. If I put the aircraft path with a clearway in, it still doesn't change. So what you have here, you have a procedure that costs nothing to operations, because the TDP is, in this case, 5 feet more than it would be if you were trying to do this complicated mathematical sum. So we do the mathematical sums, we provide the clearway, and all the pilot has to do, he knows what this level surface is, he can do his calculations, drop down and so on, and work out exactly what his TDP has to be. And that works exactly the same if there's an obstacle there. So if there's an obstacle there, the surface has to be elevated to clear that obstacle. You still have the same geometry. If you fly to it, you still have this complicated sum of working out the min dip and the takeoff distance required. And if you look at these two surfaces over here, if I put a clearway in, those two surfaces, if they change, they get lower. So it's not a big deal. So that's why you have a clearway, because it costs nothing, but it simplifies the calculation for any pilot who has to work out his performance for the takeoff. Is that understandable?
I think it is really, well, I'm not expert on this, and I got it. So, so thank you, Jim, for that explanation. If you don't mind, I kindly ask you to share also that a small presentation so we can publish that for the people reference. It still will be on the video as well. Thank you. We have one more question. It's in Spanish as well. I will show it in both. It's about Alidex, I think, but let me show it on Google Translate. Bear with me a second. So I don't know if you see my screen, maybe John or Jim. The right one is in the translation, Google Translation.
Yeah, Fabio, it's John here, if you can hear me.
Yes, we hear you, John. Thank you.
Yeah, I'm reading the question there, but if this is to answer the drainage directly into the sea, there's now going to be an introduction through IOGP where there has to be a catchment area for the drainage from the helideck, but that is to facilitate an incident or an accident on the helideck with both helicopter fuel or with the firefighting system if they're using foam, so as we don't drain that into the sea directly. So it would be a bunded area that has to be formed. That's going to be a new requirement in IOGP 690, which it will be the new section 690-6.
All right, thanks, John. So I believe that those are the questions that we have from the audience by now. So I think that we have reached to the end of our webinar now. So I will kindly, I would like to thank you again for all the panelists on your support, even late time in the European hemisphere. So thank you for your time, Jim, John, Arturo, and Maria as well. I would like also to thank the interpreters and the administrative team that is supporting us with all the setting of this webinar. And finally, thank all the participants of all your organizations that allow you to participate on this event. And also for those who were asking again, we will be having these videos on the website for you to share with all your colleagues in both in Spanish and in. So thanks again. Wish you a happy weekend and hope to see you soon on a future related event. Again, thank you.
Thanks, Fabio.
Thank you.
Okay, thank you, Fabio. Just one point, if I may. I was asked a question on performance earlier. It's about the rejected takeoff distance. I can't remember who asked it. He asked it in English. Can I say that there is an operational document 10110 10110, and that is a document that was written. And I was one of the authors on that some years ago, and it's about performance. The person who asked the question about the rejected takeoff distance, if they look up .10110, then they will find the answer. They will find a whole bunch of diagrams and so on performance that will answer their questions better than just listening to a narrative. So if I could point them towards that document, that they will find that useful.
Thanks, Jim. I actually am writing that down on the Q&A so that we remember to put that also on the table that we'll publish. Great. Well, thanks again and have a happy weekend to you all.
And you. Thanks.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you, Fabio. Bye.